Welcome! I think everything should work now. I had, as always, a bit of technical trouble. For some reason, my mouse cursor was gone, which was a bit annoying. Um, but yeah, now everything seems to be working. And yeah, last week there was no stream because I was traveling. But I'm really eager to get this into printing state today. I'm not quite sure if it's really possible, because it's quite a lot of work still. But I'm optimistic that if everything goes smooth, we're not hitting any like major hiccup, that everything should be ready to print something tiny little bit. Hi, there, Steve. Welcome. So, yeah, where were we? Let me quickly switch the camera. See if I can get this all in view here. Nope, that's my laptop. Let's see. Yeah. So that's where we left off last time. So we made the executive decision to not use this board that comes with the kit, but instead we use the normal Wago connectors here that are the standard for the 2.4. Hi, Alex. Welcome. And yeah, so besides that, I think we are kind of ready to just add cables here. Um, we need to quickly check. There's some wiring guide from Formbot, but it's very vague. It basically just tells you like where to put the connectors, but doesn't really give you an idea how to route stuff. We do have this supplementary GitHub guide, which has an image of the machine, but it's a different size. So it's not 100% what we have. And also like we now have these Wago connectors here. So let's see how it works out. But I would just like try to follow this GitHub guide. Let's quickly jump in the manual, just to make sure that we are not like skipping anything. No, I did not open that yet. Let me quickly check where we are. Yes, that's roughly where we were. So we placed all the hardware. We skipped over this end stop here because we don't use it. We have tab. And then yeah, the Y end stop, which we said we would do when we do the wiring. Our Y end stop is a little bit different. I'm kind of like hidden here behind the machine. So how about we just start with the Y end stop? Although actually, let's not do that yet, because then we also would need the chain. So the Vega mount here, what you see in the manual, is exactly what we have now here in the machine. So this is 1-to-1 the same. Quickly get this stats up and running here, so I see if something goes wrong. We did install the power inlet, which we have on the back side here. Then we also had this discussion with the direction of this motor here, where we have the connector now here on the outside. We don't have this power supply. We have the big power supply mounted. Pi we don't have. We have the solid state relay mounted. So that leaves us with the next section, which is the controller board. I would suggest let's start also with the controller board. We have a lot of stepper drivers that we need to populate. So maybe that's a good starting point. Hi there, Jordy. Welcome. So let me try to show you a bit closer up. So we have a controller board and we have stepper drivers. We have 6 stepper drivers to be precise. So we have 1, 2, 3, 4 for the 4 Zs. And then we have 2 for A and B. So it's like the XY motion system. We don't have a stepper driver here for the extruder because that is on the toolhead board directly. So the controller here doesn't need to do that. The only problem I have now, let's see how I can organize that, because the manual is basically behind. I don't see anything of the manual. Let me see if I can. How did we do it last time? Because last time I was able to see the manual. So let's jump into the documentation of the M8P, which is our controller board here. And I think this is the older version. Oh yeah, here, M8P 2.0. So the 2.0 is quite easy to see. It has this fancy drawing here. You don't see it anymore because we placed the CB1 on top, but we have the V2. I mean, you also see the chip is much bigger, it's different layout. So let's jump in here and jump to the stepper drivers. So we do have TMC 2209, so nothing special. So let's quickly check which one is this. Yeah, so we need to have this one here, which is the TMC 2209. And the important part are the jumpers. So you see like these like massive rows of jumpers here. So we need to place one jumper. Let's see. Where did I put them? Here. There's actually not much left in the box. Like I put everything out that we need today. There's literally nothing left. Okay, let me see. There's a huge bag with jumpers. So we need 6 of these. And this is like looking next to the red. It's one free, and then we have this one. And also just to double check, it's the closer to the cap. Yeah. For some reason they are red here. They are black in the schematic, but should be fine. So we have this one here. And actually too small. Too short. So this one here. Really have to get to on my toes. Maybe let's also turn that just 90 degrees. And it's a bit easier. Okay. So they're just labeled through motor 1 to 8, so it doesn't really matter which one we pick. We just later, when we do the config, we have to pay a bit of attention there. We can also maybe just quickly double check with the supplementary guide here, because they have somewhere at the bottom where we were. Here, they have an image. Yeah, they also left the one. They left this one free. I don't think it makes any difference. We really just later have to pay attention with the labeling. They actually have 7 steppers connected here. Oh, because this one is an older version, and that didn't have an umbilical. 1, 2, 3, 4, 5, 6. Yeah, so we will have 2 free. So that doesn't quite apply to us. Let me actually remove this one extra jumper here. Okay. Here we go. Okay. So then these are ready. So the last 2 will stay empty, which is motor 7 and 8. I was actually checking, and maybe I didn't see it, but I didn't see like a configuration provided by Formbot. Because in the GitHub there was nothing. Oh, I missed the complete chat. I'm so sorry, guys. Yes, this is, oh no, this is not the Manta, Jordi, it's the M8P. I think they are quite similar, but a tiny bit different. I think the Manta doesn't have the inbuilt compute module. So this one here is basically our complete board. So this is the like Raspberry. It's a big TrueTech CB1. So you'll see that it has an Ethernet port here, 2 USB ports, and this is basically internally connected already. Hi there, Mr. the DSI, welcome back. I just upgraded my Voron V0 to the Menta M4. Only mistake I made was buying the CV1, which doesn't has DSI support, so my screen wouldn't work. RPI, Raspberry Pi, CM4 is on the way. Yeah, this is also the CB1. I don't think I will have any issues with that missing, but yeah, the only thing that I noticed on my I have the same CB1 on my Switchwire. The only thing that doesn't work is WebRTC, like this different webcam protocol that I'm usually using. That is not working on the CB1. The CB2, I think is the newer one is called. That one supports it, so maybe I need to upgrade. Where? Oh, where did I place the rest of the step motors? But besides that, everything is up and running. And hi there, Neo. Welcome. I'm slowly working off the chat messages. And you still need one in motor 3. Yeah, I still need one in motor 3. I think like the image they show, that doesn't really apply to us. Like, I mean, like, which one we leave out doesn't really matter, right? It's just later configuration. Question which stepper goes where. But we definitely need all 6. The nice thing about the M8P is that it actually supports 2 different voltages on the board. So you see here, you have the motor power connector and the power connector. And actually BAD has a separate in as well, which is quite cool. The cool thing about this is that the steppers here, I think we actually need to add a couple more jumpers here on the back. They're also missing, I still see. But these are either fed from the power or the motor power. And power can be, I think 12 or 24, but motor power doesn't really matter. So whatever the stepper drivers can take, you can put on motor power. So on the M4P in my Switchwire, I have 48 volts on the motor power, which is not really necessary, to be honest. But it's kind of like a cool thing to have. The M4 is saying it's really nice to use. Yeah, like on my Switchwire, I actually use it. The reasoning was that the 24-volt power supply was just like at the end of what it can do. Like I had power issues where the heaters wouldn't, like the hot end and the bed would not stay properly at temperature. So I had to add the second power supply, and I was like, yeah, let's just try 48 volts for the steppers. And I have the TMC 5160 in there, and they can take 48 volts as well. But to be honest, like I didn't see any massive performance jump, which most likely has to do with me not giving it enough amperage, and also the Core XZ is seemingly not the best motion system for speed. So let's see. Okay, so we have the 6 steppers in here. We have the heat sinks on. Let's get rid of these like little like info cards that come with the steppers. Don't really need these. Let me quickly grab my little trash bin. Kind of keep a little bit of order here. And then let's jump back to the M8P. Exactly. So the next step is here driver voltage selection. And I'm not quite sure. It says HV and VBB. I think what we want is VBB, but it doesn't really matter, to be honest. Like worst case, the stepper drivers don't get power because we don't connect something to motor power here. So there's not much that can go wrong. So let's just select VBB. I think VBB is what we want. So VBB is on the red side. That would have been easier before, but as always, I like pain. So the most difficult way of doing stuff, that is how we do it. Okay, so basically this jumper, it has like 3 pins, and if you connect it on the right side, from my perspective right now, it will go to the power, and on the left side it will go to the motor power. So you really can just select what you want. Then the CV1 we already have installed. Fans, let's do that in a second when we do the wiring. Also, we don't have any fans. Like the fans will be installed here on the sides, on the skirts, but we don't have skirts yet, so I will just skip over the fans for now, which will be fine. You need 1.2 amp plus to see an improvement in 48 volts. Yeah, I'm actually running it at 1.4 or something, 1.5, something like that. So it's like the mid ones. And there is a difference, but it's not massive. Like it's not like doubling the performance or anything. It was, yeah, quite a slight bump. Um, yeah, now they go in all terms of wiring, but that's actually not really needed for us. So all the important stuff is here. Then that, well, like all important stuff for the steppers. So let's jump back. So here they now list all the different things connected, but this is also for, what board is this? I have to kind of like, this is some other board. I don't see right now what kind of board it is, but yeah, not really concerned for us. Yeah, you see they do similar things. So I think this is like very good time to like move away from the Voron manual, because now we are like in a territory where it's really like about the kit. So we have 2 options. We can either follow this guide here, but it seems to be a little bit outdated, or I don't have to open actually. Formbot has also diagrams, I think it is. A wiring diagram. 19.6 megabytes for a PDF. I like that. Let me open that in a separate tab. So this is the wiring diagram they give us. So I would suggest we just follow that. And from the layout basically of how the cables route, we just have to figure it out as we go. Stealth Job. No, it's not on Stealth Job, but I actually will move them back to Stealth Job. I have the TMC plugin on for Clipper. I always forget how it's called. There's this TMC plugin. It's really cool. Like it has a database of all the stepper motors. And you give it the model number of your stepper motor, and then you just tell it you want performance or you want silent, and it will set all the stepper parameters for you. It's really cool actually. So that should take care of all these like weird little settings that you don't think of. And actually had really good success with the Creality stepper motors on the poor man's Quarks we were building. I put that plugin in, and like the stepper motors like were way better. Also reduced vibrations and everything, so it's really, really highly recommended. TMC Autotune, I think it's called TMC Autotune. I don't have it on top of my head right now. Okay, so this is basically how we want to wire it, but just like to get the quick overview. Let's go back here. So just like to see, because he kind of placed the components in the same, or like in the same layout, just to see like where they place the cable channel. So they basically have a cable channel on the outside here, one in the center and one on the other side, and then like short cable channels on the bottom. I would suggest we follow that somewhat, just like from a layout of these cable channels. Let me see if I have to cut them to size, or yeah, we definitely have to to cut them. I think the only one that fits like out of the box is the one in the center. There's also the cable here. Going back to our first build stream, I think we installed the Nevermore already, and this is the cable of the Nevermore. We I don't know, 1.5 months ago or something taped here, which is way too long, which I think this will be like quite a common theme of the cabling here, that we have like quite long cables we have to hide somewhere, which is great. You know, rather cables should be too long than too short. But still like will be a bit of work. To like just hide them. I might consider at some point later on, you know, like when everything is in place, I might recrimp the cable and cut it to the proper length. Okay, then so yeah, we kind of really have to put it between the motors here. There's no other space. And then we put one over here. I wonder if we can, I mean, now it's a bit late. I'm wondering if we would be able to shift these DIN rails all the way to the end. With my thinking would be that we have like free, like basically the base free here. Then we can put one more cable channel just over the full length here. In the picture, you can see they kind of chopped it up a bit. Would be nice if you can just, you know, have it in one length. And then the other thing what we need to do most likely is, in this one, I would drill a hole in the bottom that lines up with this hole. Then we can put the cable through and we can just like put this one nice smack dab centered. So I think that kind of would be the layout I would go for. Hydrogen. Yeah, I'm not sure if nobody has any better idea. I would try to do that, but then let's actually quickly try to shift these DIN rails over a tiny bit. The only one that's annoying is like the one below the power supply. I think everything else can be relatively easy. Just thinking if I loosen it, like, no, we have the extrusions here, so it will not fall down. So, no, I lost the screw. No clue where that fell down through. And the other problem we had was that the clips were extremely stiff. I'm just using like a Allen key to kind of like remove that. And let me quickly grab a flathead screwdriver. That should work way better. I don't want to break another one of these clips. I'm kind of done with that. So let's see if we loosen that. And we really just shifted one over to have it like this. That doesn't hurt anyone. And then we have like nice space here in front. I'm not quite sure where the screw went. I think, oh yeah, I see it. Ah, it's way too far. Quickly grab. Grab a fresh one. Okay. I'm really trying to be gentle with these things now. And just like bend it out with the screwdriver. And then it clips in place. Okay. Let's see. So with this one, we can do the same. The only problem is we also have to quickly loosen this bracket here. Let's do the same here. I think that's a much better layout. To be honest, it wouldn't even hurt to shorten them like a little bit, like the DIN rails, because we don't need that much space in this build, because we have everything integrated. Oh, I was like, where's where's my bit? It's still stuck here. Yeah, like the ones I printed on this one, like they were quite okay. Um, Here. You probably haven't seen, but Gina is adding a ComShim in Octoprint 1.12 that will allow plugins to middleman printer communication. Her POC plugin will be to control her Clipper printer. Oh, that's nice. That's cool. No, I did not look into Octoprint 1.12 yet. Like the last months, I was really like underwater with like apartment stuff. Was that a correct screw for here? Seems a bit short. I completely lost track of like a lot of things. No, the screw is too short. Did this now magically get shorter, or is it the wrong screw? I don't see another screw flying around here. It should be just a tiny bit longer. No, it doesn't. Doesn't go in. Let me quickly check if we have like a slightly longer screw for this one. Like an M4 button head. Might be the easier way. We should just dump all the screws in here. I'm not sure if we have like... I only have the M4 by 6 that is not working. Look, that's literally the only M4 I have. But why does it not work? Let's quickly try here. I already see this will be a long stream if we want to print today. Well, we have a long weekend upcoming, so I'm kind of like excited to work with the machine a bit and like tune it. So I'm really, yeah, it works. Really excited to get it working. It will probably be a bit because 1.11 just came out. Yeah, exactly. Like 1.11 was relatively new. Yeah, it doesn't, it just does not work here. Okay, I'll just leave that for now. I'm not quite sure why this doesn't work anymore. I'll look in my screw assortment for like a slightly longer M4 screw. And I'll use that instead. I'm not quite sure what the fuss is here now. But I think the problem is partially because we have this part like reversed basically. It's like meant to be on the other side, right? So there's like indentation on the other side here. So we need a slightly longer screw. I think it's a problem, but I'm not quite sure why it worked before and now it doesn't. But yeah, it's not like a critical part. It's just like to stabilize the power supply here a bit. So yeah. Looking forward to it because I can probably get a tight integration with my Bamboo plugin. Oh yeah, true. That's still in beta, right? Like I don't think you updated that. Okay, let's just shorten that. I don't think we need to have it like very precise. Let's see what this does. So that goes here. Let's make one more of the same length. Okay, so that's 2 for the sides. Then for center, let me check. We can leave it just like as is for the center. And then for the horizontal one, I think we need the same size as these. Let me just make one more of that. And then this should maybe, hopefully. Oh no, this one needs to be a bit shorter. Okay, let's remove a tiny bit more. Yeah, now it's good. Okay, let me also cut the lid. 1, 2. Okay, here we go. And then this would be all our cable channels. And then for this one, maybe let's quickly do that now. I don't have a drill here. I think I have this, but it's like not really going into. Okay, let me quickly grab a drill. Then we can make a hole here that matches this one. Then we can already have that properly. So it's really just on the height of the, like if I kind of like align it on the back on the second notch here. Let's just drill a hole in the bottom. I'm right back. 1 second. Here we go. So let's just do on the height of the second, roughly center. Okay. And then we can put this cable through here. And then this is nice center, clean. I like that. They provide us with this tape here, which is like a fake VHP tape. I do have one-click printing for orchestras working as of last weekend though. Oh, for the Bamboo Lab, but they changed that, right? You need to have that integration with this. Oh no, you. How does it work then with Bamboo Lab with the Bamboo printers? Because you technically, I thought you need to go through their new utility. Ah, okay, 1 second. Let's remove that here. It's really awkward that I have to do everything like basically up here. Maybe I can kneel on my chair. That makes it actually better. So let's put that here. Grab a knife. Outside of a stream, I would never do it like that. like being here. But yeah, it needs to be all a little bit like visible. My most favorite VHP tape. It's always fun peeling off the backer. Okay, so check that this is somewhat straight. And yeah, no, tape is actually like, I mean, holds fine, so I'm happy. So that's one. Let's just do the next one. It's most likely super, not most likely, it's extremely overkill to just put the tape on the entire length of that entire length of the cable channel. Like it's plenty if you have one, two spots basically where you would tape it down. But we have plenty of the stuff, so let's just go for it. Okay, that is this one. And the next one. You just uncheck the box in the printer profile that identifies it as a Bamboo printer. Then you set it up like any Octoprint Clipper connection, and it loads the web interface for the device step instead of loading their network plugin. Ah, I see. Okay. But then you also lose any. I'm not quite sure if there are any like Bamboo specific G codes. I'm not quite sure. Like I never worked with Bamboo machines. If there's like any G codes that are like specific to Bamboo Lab that need to be included. I'm wondering whether we should quickly remove that inlet here. Might be. Maybe you can also. Yeah, that might be good enough if we move it around there. Okay, let's be careful with this. And then you can just place it like this, I guess. Oh, maybe we could have even left it longer. We know it's too late. Because like I see now like it kind of goes under the motor here on the side. But it's hard to close. I think this is fine. because this will already be like a bit annoying to close, because it's like under the inlet. Yeah, maybe it's best to just fold it over here. Okay, let's just open all of them for now. And we actually have some small bits and pieces of cable channel left, and actually like one complete length. So I give plenty of this cable channel, which is good. Okay, this is not very comfy, but it makes me a tiny bit taller, which is nice. So okay, then let's start cabling. Let's start cabling. So we have one big bag of cables here. Let me actually see if I can reorganize this a little bit, that we have like a little bit of like space next to it. Just use this as big trash bin. Okay, let me see if I can move this over a bit more. Then we also have a bit of space here. Get this all in. I'm glad I didn't go for the 350. And also, before I forget, because this is something I will most likely forget, this is the Wi-Fi antenna for the CB1. It has a little connector here in the back. So maybe we can literally just tape it here or something and just see if that works. I'll put it somewhere. Let's just put it back. But yeah, most likely we'll forget that. But when we turn on, most likely will be helpful to have the Wi-Fi antenna installed. All the G-codes are still in the printer profile, so sliced files work. That's nice. Yeah, that's a very nice workaround. That's a very nice workaround then. Yeah, so let's use the space here on the side for cables. Let's just unpack what do we have here. So these are for the XY motors. Let's leave them for a second. Power supply to motherboard is something we can already wire technically. Maybe it's smart to just start with the AC wiring though. That's something you don't want to forget. I forgot mine, and it took me forever to find out why it was not connecting to Wi-Fi. Yeah, actually, I tested it out at one point, and it like it was on my desk, and it connected fine, but it was like super close to the Wi-Fi router, so that most likely helped. So we have quite a bunch of cables here. We have a couple of cables that have these, I don't know what they're called. I think they're called spade connectors. So these are all for the wiring of the AC area here. Let me. Which side can we see that best? I think maybe actually from here looking onto it. That is something that is in the Voron manual exactly here. So we have the inlet and the switch. So the inlet and the switch. So we need one connector, which is short brown and slightly longer blue. So we have short brown and slightly longer blue. So this goes from the right side to the bottom here. But yeah, discussion we had before, like when we were wiring up the V0, technically the blue and brown don't really matter because like where I live, you can just plug the connector in both ways to the wall outlet. So it's more like a theoretical. You know what? It actually would have been nice for this motor also to face outside. I really don't like mixing AC wiring with like other stuff too much. And now the stepper cable here directly is where the cables are here. That's maybe something that we might also maybe we also swap that, right? Like swapping this one over was like no big deal. So potentially maybe we should also do that here, because if it works here, it works here as well. And we have to a little bit separate more. It's just like it will be like quite hard to plug in the cable here because you have the skirt. But then like we don't have the skirt yet, so yeah. Let's see in a second. Then we have these cables, which go. Oh, now it gets funny. So this is from the power inlet. They say, of course, on the side where they are. Let's see. They now have they are crimped with a spade connector. No, these are called spade connector. I'm not quite sure what they're called. The problem is we need to put these on the Wago clamps. So this should go down here. And I mean, it's quite random. We can still decide which Wago clamp is what. So this needs to go here. And then we have the last of these cables with these connectors, which goes on the last remaining plug on the inlet. And that's the protective earth. So technically we can just have this like this. So here's the thing. For the Wago clamps, you don't need to crimp any connector on. They can just accept bare wire. I'm a bit sad we cannot move the label here. So it's like heat shrink label, and they made it in a way that we can't move it. So we have to get rid of that. So what I will do now is I will just cut the cable to length here. But looking at that, to be honest, maybe it makes sense to, yeah, let's put the protective earth on the first one. Let's put this one here. So these are the three Wago connectors here. So let's just cut them and put them in. The only thing you need to know is for the Wago connectors, you need 11 millimeters basically of bare wire. So it's quite a bit. They actually have like a little like drawing on the side. I will scientifically guesstimate 11 millimeters. Yep. Okay, let's just make sure this is like properly in. Here we go. Good practice, not mixing AC with DC wires. Yeah, I tried to keep it separate, but then yeah, it's like quite a lot of tight space. So I don't think we will be able to do it fully. But I think this connector here, I mean, there's separate here, so I don't think we can fully prevent it, but at least like here where it's like super clustered, you know, I don't want to have like an extra plug here. So let's at least try to get this straight. Oops. I lost one. Yeah, for the Wago connectors, just make sure to have like the cables properly in and no copper showing in the front. It's a bit annoying. Maybe we can loosen that quickly. It might be easier to put the wires in when it's not in place here. Or you would like this. That also works. Okay. And then the last one. So here this label gets in the way a bit. Let me just quickly try if we. Yeah, you can pull it off. Okay. Let's see if we can. Yeah, here we go. It's a wee bit long. Maybe a bit short. No, it's a bit long. That might have been a tiny bit long. Let me see if I. Oh, it's fine. Okay, perfect. Okay, so we have our 3 Lego blocks. Lost some of the cable here. Okay, let's quickly swap the motor. I think let's just do that. Nothing to lose. Nothing to lose. Just rotate that. But now that we have, yeah, I think we need to like modify a couple of the cables for this. I don't think this will work out of the box. Because this, for example, yeah, this one would need to go all the way here. So this is definitely too short. This one is like, I mean, it doesn't really matter, right? This one is the length we can use. So that would be just enough. This one, I mean, it's really only, it needs to go here. So yeah, it's just like a wee bit too short, to be honest. It's just tiny bit too short. It's like a centimeter too short, which is a bit annoying. This one is easy peasy. So we have one more brown, blue. Yeah, so these are really short now. So that will not work. So if you do this here with the Wago, you need to have a tiny bit of spare AC wiring. Easy to get, but the problem is that you have to crimp them. So if you do this with the Wago and don't use the, where's the board, like this board they give you, that annoyed me last time so much that I didn't put it in, then you need a little bit of wiring, and you need to have at least like the crimp here for the spade connectors. So yeah, I mean, if you follow this as tutorial, like, it doesn't change a lot if you use the Wago or not. But yeah, let's also move this one a little bit back here again. Then motor, we want to turn the motor a bit. So let's loosen the screws. And then we can open this lever. And how did that work? Yeah, the only problem is like we added now the the skirt here already. So I also have to loosen the skirt and hope that we can, yeah, that works. Slide over and we can access the screws here. Easy. Let's just get the cables out here. We have a bit more room. Oh, give me the screw. Okay, then we just rotate that 180 degrees. To be honest, you could also get away with just having the connector face up. think there's enough space between the motor and the panel. Would be like super tight, but should work. Here we have the last screw. Okay, that's that. Then let's close the lever. Motor is tight. Now we can just slide the skirt back. And nothing ever happened here. Cool, then this faces out and this faces out and these two face in. Then let's continue our wiring session here. So for the solid state relay, pay attention to the orientation. So one side is labeled input and one side is labeled load. So the input is where we want to have the input. Let's do the following. Let's use the cables that are actually labeled SSR for this. Oh, am I missing something? Yeah, here. This one. Okay. Maybe let's actually first wire up the PSU. Then we can do all the other stuff in one go. So for the PSU, I'm just going to use the cables that came with the kit. We need IU. That works. So I hope I get it right. Brown is load, pretty sure, but I'm not 100% certain. Then we have the protective earth. This can just run here. That's actually perfect length. We can just cut it as is. And this one is quite long. And then we need a neutral wire, which this one is a bit short. Let me see. This is some solid core wire, but it will be not super fun to work with. But this is perfect for us. So this is just like random cable I have from like another project. The only problem, and it's something I will fix later, this was like to wire up a lamp. And for lamps, the color code for EU is black for the load, not brown. So this cable is black, not brown. So I will switch that out after the stream. I just have to quickly hop to the hardware store and get some. But the blue will work for us. So let's crimp one side. These crimps are super easy. So if you follow that and you want to do it yourself, these crimp kits are very cheap. I think it's very handy to have anyways. Let me see. That's the one. So they use red ones. Let's use the same. Here they are. Well, just put them in. Make sure it like peeks out on the front. And then you can just squish it. I always squish it twice. Controller connecting to the transformer or what? What are you going to build? I'm not quite sure if I can follow you. Not sure what you mean. Let's give this a bit more length. So this is like this. And just run them in the same slot here. Yep, go in. And then this one goes out here. Oh, where? Oh, there we go. Yeah, Wago connectors are amazing because you can have like such a wide range of cables or like cable types in there. Like they can be crimped, they can be plain cables, can be solid core, can be stranded core, can be like super small cables, can be quite big cables. It just takes whatever you throw at it. So, only problem is we have to maneuver this in here. Okay. And the labels are now incorrect, but yeah, I can live with incorrect labels. What I cannot live with is incorrect cable coloring. You really have to pay attention with that I mean, in general, but like for AC wiring, especially the cable color is like really important. Okay, so this is AC for the power supply. Oh yeah, before I forget, like they have this like very badly visible translucent cover here that we can later put over the connector here. Vehicles can fit from 0.14 to 6 millimeters square. Yes, but there are different versions, and they all look the same. Like from the 2 to 1s, there's some that can they have like they can't clamp the very small wires. But I'm not quite sure why. Like they visually look the same to me. Okay, then let's quickly go through the manual how we wire up the solid state relay. So looking at this, what we don't have this like 25 volt, the 5 volt PSU here, because that's used to power the Pi. We don't have that. So we wired up the LRS 200, which is this bad boy here. And now what you need to do is the solid state relay. So on the, yeah, exactly, I have it wrong. Do I have it wrong? Yes. So it says AC load. Load is the side on the AC side. Okay, so we need to wire up on, it also says terminal 2. We need to wire up the load, which makes sense. So let's create the load cable. And as I mentioned, like this cable is now black. Black is quite suboptimal. I will swap it out for red. They use also spade connectors, so let's just follow what they had in the kit. I was hoping that I get through that build without crimping. I think spade connector crimping doesn't really count, so. Okay, so that goes in here, goes out here. Yep, you also have 1.4 to 4 millimeters squared. That's strange. Never had that issue. Yeah, like I don't know, like there must be a reason why they are different. But I'm very certain there's also like one version that doesn't like it's not meant for like very thin cables, like the ones that you like something like this. I'm not quite sure what the difference there is. Okay, that's wired up. Then we have the protective earth again, as always. So we need one with a spade connector on one side. Yeah, but yeah, so if you build this kit, I really would recommend you just get like one of these kits. Like it will come in handy at some point anyways. And just go with the Wago connectors. I think they're just like much more flexible. I mean, you also have the option now to add more stuff. So if the need arises and you want to have like another thing in here that uses AC, you have enough capacity. And it basically just goes. Oh, wait. I did something stupid. Wrong. This goes in the center. That would have been quite a firework. Yeah, most likely not a firework, but it would have at least tripped some breakers. It technically is crimping? No, that doesn't count. Let's see. It really works well, like if you bend it a little bit, and then you can just slide it in. Over here. Perfect. Okay. Then the bad cable we don't do yet because the bad is not installed. So the bad cable will come in here. So that's something we need to do later. But let me quickly take a quick peek at the cabling. Uh, yeah, so this is the cabling we get. So me see. The one will go to terminal 1, which is this one here. And the other one, the red one, will go to... Why do they wire that on the PSU? That's a bit weird. That's a bit weird. I'm very confused by the coloring as well, because it's like blue and blue. But yeah, one is neutral. That's the blue one here. Neutral is the lighter blue. So the lighter blue goes onto our Wago here. I don't see why we would wire it here. So it goes on our Wago, and the other one, the darker blue, which is labeled for SSR, will go here on the one. Okay, but that is for later. Okay. Then I think this is all the AC wiring we need to do here, minus the bat. So I would think, let's see what the next step is here. Exactly, like you also now describe here what we do with the Wago. Yeah. So now they show it exactly what we have now. Maybe it's good to double check just to make sure we have everything correct. So we have 2 blue ones, we have 3 brown ones, we have 3 protective earth. 1 protective earth goes to the SSR, 1 protective earth goes to the power supply. 1... Oh, wait. They don't show the cables from the inlet. So we have -1 on each because we don't have the 5 volt. So we have 2, which is what they have. 1 goes to the solid state relay, 1 goes to the LRS 200. We have 2 blue ones, or like 1 blue one, which goes to LRS 200. We have 2 loads, 1 goes to LRS and 1 goes to the port 2 of the SSR. So that's correct. And then basic from the print bed, that's exactly how we will wire it up as well. We will have 1 more protective earth that goes here. And the print bed cable also has the one that goes to the frame. And then we have 1 more neutral, and the load will go here on 1. Cool. Okay, then this is the other side of the SSR. Let's just see when they... So they wire up now to 24 volts, so let's do that first. Then I think for now we are out of crimping territory. Nothing happened here. We are fully following the instructions of Pink. And this is super, super messy here. Let me quickly put all the tools back just to reset quickly. And we have a couple of like cables we cut and don't need. Like these short ones, I don't think we have any need for them. So let's keep them for now, but most likely we'll just throw them out. Then we have the power supply cables. Yes, so this is 2 jumper cables. So we have to seemingly connect power to motor power, which I didn't know. And then we have the 200 watt PSU to board power. So that's basically the run we have to do here. So let's do that first. So black is obviously the negative terminal, red is the positive terminal. Oops. And then, to be honest, this is so long. No, it doesn't quite reach. So we have to go in here. And then let's just do like a little loop. And this cable I'll just put to the front for now. By the way, I added like on the underside, I added like felt, like these like felt pads you can put under chairs. So now it's like super easy to turn to turn the printer. I highly recommend that. Like that really makes it much easier handling the big machine upside down. So this goes to power. Let's flip it open. So this is, yeah, this is minus, this is plus. I really like this little lid here. Very nice. Okay, now we can just put that in here. Perfect. You still need to crimp 24 volt from the PCU to the motherboard. I don't need to crimp that. We just put that in here, right? Nothing to crimp there. This one, I'm a bit confused. It says power, motor power to power. So it would be like a little loop here. Let's just double check what they have in their wiring guide. And yeah, they show it here that you have to connect it to both. So let's just add this loop. I'm not a huge fan of like, nobody saw that, of putting like two connectors in one slot, but it's kind of okay, I guess. Here we go. But that makes me then double question the jumper we set here. Because I assumed like it's like in the M4P where basically the jumper is between the two ports. But in this case, like it doesn't look like that's the case. Let me take a look again. Because there's also no description here. Driver voltage selection. It says HV and VBB, but it doesn't have any description about what that means. Oh, and actually I put the selection on HV. Huh. Interesting. Let's quickly research that. Unless somebody in chat knows that. The cable is meant to go from hot and zero from the motherboard to the SSR. Oh, this one. We still have this one here. This is the cable. Why would I need to crimp that? Like this comes pre-crimped from factory. So I mean this is when you check hot and one is here, so this should be fine. But you say hot and zero, and this one says hot and one. I don't think it matters, but small difference. Let me see. Okay. Let's quickly check M8P big BTT driver voltage jumper. Nice YouTube video. Um, well, let's watch a YouTube video with the ad. Amazing. Yeah, exactly. VBB will select board power terminals, and HV will select motor power terminals. But then, I mean, now we set it to HV, so we need this bridge. It's a bit weird, like, but then everything is correct. So we have the bridge here, and the jumper is on the position facing my side, so it's on the HV slot. Yeah, I don't know. Like, technically, we can remove this little loop here and put everything on the VBB, and it will be fine. Like, that doesn't really add anything, to be honest. Maybe it's from an older version of the board where this was required. But you can also have like different drivers on different voltages. So I leave that now here as is because the jumpers, again, like the jumpers are on the position facing my side. So this will work. It's just a bit odd. Oh, by the way, we already checked it last time, but make sure there's a little, I just see it now, like a little voltage selector. Make sure that this is on the voltage for your country. So for me, it's 230. If you're in the US and Canada, I guess. Um, Make sure to put it to 110. Does Mexico have 110 or 230? Um, yes, then Raspberry doesn't apply to us. Then now this is the cable to the solid state relay. Um, doesn't matter hot and zero, hot and one, something to configure later. Yeah, exactly. Like these, like, it doesn't really matter what goes where. Um, where did I put? What is the specification of the board? This is a Manta M8P that comes with the kit, and it's actually really cool little mainboard. Little is relative. um, One second, let me quickly get out the right. Um, where did I not put the? I'm not good at talking and doing things. Why didn't I put the screwdriver back in the box? Um, let's just use hot and one because it's what the label says. So the board actually is quite cool. You can have up to 8 stepper drivers, which is nice. Like, we use 6 now, but technically there are 2 more, so maybe in the future. And each stepper driver can either run on the power input or the motor power input. So technically you can have 24 volt on power and 48 volt on motor power, and then you can select which stepper drivers go on motor power and have the 48 volts, for example. Then the other thing that's really cool about this board, you see in this section here, there's the CB1. It can also be a Raspberry Pi compute module. So basically it's like all in one board, basically. So usually you would have a Pi next to it, but that doesn't apply to us because we have the Pi built in. So we have two USB ports here, We have Ethernet here, USB-C here. We have two HDMI out here. So this is basically right like the Raspberry Pi section, and then this is the mainboard section. You also can see here there's the GPIO pins of the Raspberry. So it's really cool. I really like these boards. I have something similar in my Switchwire, and it's a really solid choice because it just like makes cabling easier. Because you don't have extra Pi. Everything is in one package. Okay, so this game is also quite long, so let's do the same trick and just put it in the channel, but then like run the wrong way and just loop it in the channel. Oh, that's the wrong cable. Then I don't think this really matters here. Like the plus minus is like kind of like, yeah, not super important, but let's do it correct. So basically what this does here, just like as an explanation what we are wiring up. Make sure that these are properly tightened, and let's run them out here. So how this works, so our bat is an AC bat. So basically it directly runs on the mains power on 230 volts. You do that because with the big bats, it's basically if you want to have a DC bat, so it's powered from the power supply. You just need like a very large power supply. It's not super efficient. The main board here, of course, cannot control AC. Like if you put 230 volts on that thing, like it just explodes. So we have the solid state relay here, and the solid state relay is able to like turn on and off the AC. And because it's solid state, like a relay is basically just something that can, if these two are on, like if there's a connection on these two pins, it will open the connection between the input and the output here. So basically this will just like close the loop. But basically because solid state, it can switch very, very quickly. So how a heat bed controls the power is basically every second it's turned on like 100 times, on, off, on, off. And the amount of time that's off and the amount of time it's on within the second, for example, determines the percentage of power it produces. So if you, for example, like if you heat it up, it's 100% of the time the bed would be on to heat quickly. But then once it's at the target temperature, you turn it on and off very quickly to keep the temperature where it is. And this is basically solid state relay. It can very quickly turn on and off the connection between the input here and the output that is still missing. And the output that's missing would go to the bed. And then the other cable of the bed would go directly to the blue one here, to neutral. So basically, whenever this closes the loop, the bed is on, and when the loop is off, when the loop is broken, then the bed is off. And all this does is basically it allows the main board to control the AC bed. Not sure if that made sense, but I gave my best. What is DSI? A CB2 which also supports DSI. If you follow the Voron binding diagram, there's a config file for M8PV2 in the Voron GitHub. That's a very good hint because I was looking for config from Formbot and there was none. So I would have just looked for a default Clipper config for the M8P and just start from there. But then I will definitely check that out later. Cool. Okay, so that is done. We wired the 24-volt PCU. Oh, they also show the loop here. Interesting. Okay. But this is different main board, so maybe this stuff is different. Then this is to the solid state relay. We have that. Then the Z end stop doesn't apply to us. And the TB is a thermistor bed. We don't have the bed installed yet, so we skip that for now. Then motors. So this will be like something to keep now track of. That will be fun. We have motor cables. I think what's easiest, are they all the same length or are they different length? They are all the same length, which is sad. That means we need to hide more cable. So what I would do now, let's just plug, so we have the motor 0, 1, 2, 3. Let's just align the motor numbers with the Z. I think that's the easiest to later keep track. And then basically motor 4, 5, the last two, that would then drive the AB motors. Oh, that's the wrong side. Okay, why does it not go in? Okay, perfect. So lots of cables. Then on the front, let me orient the, because I'm looking here at the manual, let me orient the machine exactly how it is here. Then let's start with Z0. And I already found like a bug in my wiring because we need to go here. So we need to, let's do the last. Then Z1 is this one here. So let's start with this one that just goes all the way down here. Goes here. Oh shit, that's also too short. Oh, seriously? Let's see if we can move the board a little bit. Yeah, like it would have been perfect if we wouldn't have flipped the motor around. That's a shame. So those cables are relatively short. If we moved the bed a little bit, this would fit. So I'm low-key considering just flipping the motor back, to be honest. Ah, that sucks. Oh, my beautiful wiring goes out the window. I guess we have to... We have to cut some corners here. That is sad. Now we'll have like this ugly wire here. I most likely will replace it. You know what we could also do? We could, instead of using the last four, we can maybe shift it just down. That gives us more wire length. Yeah, let's quickly do that. I think that's the easiest solution. So we just shift the, I mean, we don't have to shift them literally, but so the first one, we also have to move the jumpers. That goes here. That goes here. I will leave the jumpers here on the back. Let me quickly see if I can use tweezers to get them out. Yeah, that works. So we just shift it over. And it just becomes a bit more. So my thinking was like with using these, like it's easier in the config layer to align the Z motors. No, it's a bit more complicated, but it is what it is. And then we literally put this one on the last, because then we have enough cable to actually run it in the cable channel, I hope. But yeah, should be good now. Okay. Okay, then let's do the following. Let's quickly add like a little mark to the connector here. that we keep track which connector goes where. So we have one with one strip, then we do one with two strip, and we do one with three strip, and one without. Then we later can easily track which motor has which wire. Then for now, it doesn't really matter what goes where. We have to later figure it out with the config. Just plug in this one here, and we just loop the stepper wires in the cable channel here. Let's put this one also properly in. Now we have to feed that through here. That is fun. So zero is front, left, and counterclockwise. Yeah. I think it's now it's out of the window. Let's just fix it in the config. Because like this one is now Z1, but it's the last motor. So ideally, like I wanted to keep the order of the motors here the same order as the stepper numbers. But we can't do that now because like I really need this one to be on the absolute last to make this run. That's a bit of a shame. Nope, I accidentally grabbed one cable of this one. So this one goes here. Okay. And last but not least, this one we definitely have to run completely haywire around the back here. And even with that, I'm not even sure if it's long enough. So potentially this one we need to swap to the to another stepper. Oh, might just be long enough. Yeah, it's just long enough like this. It's not pretty. I don't like this. Like I like my cables and cable channels. So I think, yeah, the thing's like if you would shorten the rails, like if you take like a couple of centimeters off the rails, like it doesn't really hurt, and then you can have one more cable channel here on the back, at least like in this section, and then you can hide this cable. Because lengthwise, it's fine if you use one of the further, like stepper models further down. Let me actually quickly check. Where did I put the trash? Here. I mean, maybe we can do this. Just add a tiny cable channel here. Add a tiny, we have to shorten this, but if we add one here, and then it just runs under. Yeah, let's do that. That sounds like a plan. And then we actually have the AC wiring completely separate because we don't even run the stepper wire through here. So that goes here. And that goes here. Where did I put the tape? Hi there, Ravenkeeper. Welcome. A bit late to the party. To be honest, I think it will be quite a long party. Because I think, Steve, you were right. This is more work than I expected. I'm just adding some VHP tape here. Yeah, so if I would not be on stream, what I would do now actually, because I'm a little bit like the perfectionist sometimes, I would remove the board quickly, unscrew this rail, and cut it short with a saw. I'm not going to do that now because it's a bit of a hassle, but that would be my non-stream decision. My stream decision is what we do now here. Gotta love VHP tape. It's so nice. It's kind of how I imagine hell, like being forced to peel VHP tapes for the rest of life or eternity. So I'm just making sure these are like in one line, because what we can do then, because we still had like one complete cable channel here. Let me just take like a very rough guesstimate. And then we can do this. Now it looks like one with a little with a little hole. But this is good. Then actually, if we have this now here, let's reroute these cables. Also in our new cable channel. Even cleaner. I like that. I think this is a good solution. I mean, premium solution is to cut the DIN rail. This is like the second best solution. Okay, so later we have to figure out the stepper motors. So the one without goes to Z0. The one with 1 goes to Z1. Oh, it's actually quite good. 2 goes to Z2. And 3 goes to Z3. Ha! Accidentally perfect. So we later actually can see on the stripes here basically which motor it is. That's quite good. That will help later on. Cool. Better late than never. Another stream Saturday. Yeah, maybe. We can try. Let's see. Like, I'm still optimistic, but I don't want to stream like 8 hours. So there's like a cap. But technically, yeah, we can stream tomorrow. I have a long weekend. Cool. Next up. We did that. Yes, so now we are going to the chains. Chains being singular for us because we have an umbilical cable, so we only have one chain. And through that chain, We don't have to run like tremendous amounts of cables. Technically this one, no, not yet. Let's quickly add, no, let's do the chains first. Let's do it step by step. Here it's an absolute mess. Like it's not even funny anymore. Goes to the trash. Yes, then chains. I think we need to flip the machine over. So these are all things we did already, slash we don't have to do. This is what we need. We only need the Z chain. So let me quickly. Oh, that was the transparent cover. Actually, we can put this on, right? There's nothing that we will add to the PSU anymore, so we can just add this little cover here to protect our fingers. Oh, this just confused me right now because I was like, white. Why is there a white cable? But yeah, it's the positive, negative. Perfect. Okay, let's flip it over. Here we go. I can sit for a second. That's very nice. What do we have here? Air filter? Oh, I was like air filter nevermore, but this is a different air filter. We also still have the end stop here, which we need in a second. Okay, cool. I'm not quite sure, like, do you like the overhead or shall I look for some other perspective? I definitely can bring you down a notch. Okay, so oh, now I also see the manual through the printer. Very nice. Stuff comes together. We need heatsink inserts actually. Wow. That is nice for a change. I can get my soldering iron. Oh, actually, I didn't get the printed parts done yet. Here we go. Not much left. Not much left. Let's quickly get out what we need now. Oh, this one we don't need at all. Yep, I think that's the. I mean, I didn't print all the parts, of course. I didn't print the like skirts and panel clips and stuff. These we don't need actually. Like, there's nothing left. The green ones are the tools. This one is the end stop mount. We don't need that because we have this part. I'll talk about in a second. This one is the same as this, just slightly modified. This is the Z end stop, which we don't build, and this one is ADXL mount for the stealth runner. I have no clue why I printed it. And these two, I have no clue where they are supposed to go. It looks like something belt, but I don't think we need them. Okay, yeah. Let's put it on the pile of chaos. Okay. I actually have a problem. In the beginning, I put the screws here in that box, and now I dumped all the random stuff on top. Okay. Here we go. heatsink inserts. It's only two, and they come from the like the wider side. That's it. I don't think there are any more heatsink inserts. This doesn't need heatsink inserts. This doesn't need heatsink inserts. That doesn't need heatsink. Yeah, that was all heatsink inserts. No, that was quick. They are for the Z chain. The white ones? Like these are for the Z chain. That I know. Oh, you're completely out of focus. I'm so sorry. But the little white ones, I didn't see that. Oh, also, I forgot to print two parts, so I quickly printed that. Printed these before the stream. Yeah, almost forgot. So this is the guide. We'll see it in a second, and this is the amount we need now. Okay, so we need the M5 TNAT, M510. M510 we already have here. I have M3, M5. Here we go. So we need one of these here in the center. You tell the camera to focus down here and not up here. I think now it should be in focus. Bit hard to see my small preview. Maybe you're right. I don't know. Like we will find out in a second because the Z chain is what we are doing now. So if they are for Z, we will need them in a second. They look like really like belt stuff. Then we have this part here, and that goes like this. I'm not quite sure about the position, if it's left, right. So let's see in a second. Then we have, oh, you know why you might be confused? Because like these are actually accent parts, but for me they are black. I didn't print them in an accent. So we have the chain. And the chain goes here. So it needs to be this way around, that it can bend. And then we will have this guide in a second. Okay, so how does that mount work? Maybe, I mean, lengthwise, I assume it's okay. We'll see in a second. So on the bottom, oh, stop. My Google had alarm for some reason. I'm a bit confused because like I have these like end pieces, they don't show them. Or like the ones in the manual are different. I don't think it matters though, but I can only tell you I'm on the wrong side here. So we need M310 flathead. M310 flathead. Here we go. I'm not quite sure why they have this as a separate part. Let's put in the center one. Okay, so that's the bottom mount. And on top, I assume it's the same mounting mechanism. Yeah. Let's put the screw in the center. A B belt clamp. No, they're too small. One second, let me quickly finish this one. I feel like I need to have that bit in a different spot. Let's see what I'm actually doing here. It's lost in here. Yeah, we're not sure why this is like a separate part. Oh, because it's, yeah, okay. It's like two halves and this is in the center of it. So why they opted to do it like this. Okay. So that is set on both. If I recall correctly, if you screw your chain, you can't open it on both ends. I am not sure. We'll find out in a second. It's easy to remove one screw, so. It doesn't look very nice yet. Yeah, then we have this guide here. I'm not quite sure why this is needed, to be honest. Because they place it on the outside. They place it here. Let's do that. So we need another M5. And another M5 by 10, I assume. And then this is in place, so it's vertical. I assume when the cables are in, like it will push it a bit out. So I don't know, like I would have expected this to be on the inside to like prop this up. It feels like for me like it's the wrong side, but because like now it's a bit hard to show you, but like it's like not like a nice chain run yet. Let's see if that changes with cables. Okay. Let me quickly get rid of the soldering iron because we don't need it anymore. We have more space. Okay. Then I think now we need to run all the cables. They don't, yeah, they tell us like hot end and everything. For us, it will be a little bit different because we have the umbilical cable. But let's run the cables. So we have two cables. Let's quickly check if they have different lengths. Oh, they're also labeled A and B. Then let's keep the labeling. Just to check, because one should be longer than the other. And yeah, one is longer. Then just to check, this should be A and this should be B, I assume. Do they conveniently show that to us? No, they don't. They just say AB. Oh, they do. So the A motor is in the B motor is the one with the outlet. So this is B. So yeah, I was correct. Okay, let's turn it around and run some cables. Maybe I can even put it like this. So this is the A motor. That goes here. Let me just quickly plug them in when we have them sorted. And this is B, so you go here. Then let's quickly open the cable chain. If it wants to be opened. What? It very much does not want to be opened. Now it's too open. Oh, this doesn't rotate. Sorry, I was like out of frame. Like this doesn't rotate. Like the cable chains I so far had, like they basically rotated open, so the clips were still attached. But these completely fly off. Like there's not like oh, I'm just stupid. Sometimes I'm like, okay, this is a weird cable chain. So I opened it on the wrong side. But they're also not really. Oh, okay, so never do it like this, it works. Never mind me. There's a screwdriver side. Oh, there's a screwdriver sign. Yes, there's actually. It's just me being stupid. That happens sometimes. I'm trying to show you everything. I think we zoomed in a bit. Let me zoom out a bit. Okay, so I opened all the links. There's actually none that we can't open. We just have to push this quickly through here. Maybe it's I close one link here in the center, just that the cables don't fly out. Oh god. Okay. I see another challenge incoming. Let's see if this cable. Then this cable goes to the bottom of the extrusion here. So we kind of run inside extrusion, and then the kit comes with these cable or like extrusion thing, like the slot covers. Slot covers. That's the word I'm looking for. So we run that under the slot cover. I really hope for the 350 kit that they have longer cables. Because on 300 they are already quite short. Okay, so the cable runs neatly tucked inside here. Then let's push that through here. Trying to keep like a little bit of loop here. Let me open the one I closed. I see more challenges incoming. Okay, so these are the stepper cables. Then there is two more things we need to run through there. One is the Y and stop. Which will be placed actually here on this block. So I'm just we'll let it dangle there for a second. And just push the cable through here. I think later it will be easy-ish to pull the cable a bit. So it's not super important. Something like that should be fine. And then the last cable we need to pull through here is actually the umbilical cable. So I'm not quite sure how much cable we need for the umbilical, to be honest. something we need to figure out. And that would also be a super fun cable to hide under deck. Let me see if I can maneuver it through here. Here we go. Bit difficult with the, because like different wires. Like technically you can just like wrap a little bit of tape around it. Will make your life much easier. Let's just guesstimate for now how much cable we need here, but I think it's not all too much. Just quickly. Oops, no way. So we need something around this length. But I also realized I just made a mistake. We first have to pull it through the PG7. I don't know if it's intended to do this, but there's a cable sleeve in the kit. Put all the cable in the sleeve in the chain just to prevent isolation damage. You think that's the... I'm not sure if that is what this is for, to be honest. I mean, it kind of has a length that would be sufficient. Like there are two. There's a short one and there's a short one and there's a long one. The short one is too short for the umbilical. So I'm fairly certain the long one is meant for the umbilical. But I'm not sure what the short one is for. I mean, technically you can add the sleeve around the cables in the cable chain. I don't think it's necessary, to be honest. But yeah, we have to quickly like pull that cable out again, I think. Because before we put it through, we have to add the strain reliefs. So I totally forgot that, so we quickly have to pull that out again. So first the cable needs to go through the strain reliefs. And then we can pull it through the chain. But also the Z chain is not super critical, to be honest, regarding the cable damage. Like Z is not moving a lot. Let's see if I can maneuver this through here. Because the connector is already crimped. Let's see if that is the right direction anyways. So the first one, do we have two? No, we only have one. Right? Because we don't have a PG7 on the end here. They give us two. I'm not quite sure why they give us two. Let me quickly see. So this goes. No, there's no PG7 connector on the other side. We only have one PG7 connector. Let's quickly take a look-see into the just like looking through a picture here. Um, do they show the umbilical here? Oh no, they still have the old kit with the chains. Um, no, they don't show. Oh, but see here, they also don't have a sleeve. They also don't have a sleeve in the chain. Okay, well, they don't show that, but then we only have one PG7 connector, I'm fairly certain. So I only have to maneuver this plug through here. If the plug fits. I don't think this fits through here. I don't think this... ah, it just fits, okay. Ha. Well, that's not a fun experience. Okay, back in the chain. And now we have to do this fun part again. And I think technically we can close the cable chain. Let's leave it open for now because in case I forgot something, we don't have to open the entire thing up again. But now we kind of like Loki started on the umbilical cable, so let's finish this one up. So the umbilical cable comes with a mount. So there's this PG7 mount here. And that goes on top here. I actually wanted to reprint that in white and I forgot. So now it's black. And this one is a modded one that also has a slot here for the Y end stop. So this goes in here. And then we need to run the cable a bit, but then basically this goes here. So this is our Y end stop position. So I would suggest let's first get that PG7 thingy mounted here. And then adjust the length of the umbilical cable. So I'm quickly, actually not quite sure how this works. Ah, we need to remove the bottom nut and then we can just screw it in. Check. Easy. Oh no. See, that's why I didn't close the cable chain. The cable needs to go through here, of course, as well. Fun stuff, fun stuff. Fun stuff. Here we go again. That's again like very fun to fill this cable through. I'm actually waiting for the connector to break, to be honest. Like, I'm not treating that connector very nicely. Okay, let's quickly finish this. So I screw this in here. And then the strain relief goes on top. Yes, and also grips. Let's we don't need to screw that down. Let's quickly screw it down temporarily. We still have to add the Y ends up. So we will have to remove that again. But then at least everything stays in place. What is better, Trident or 2.4? I don't think it matters a lot. The Trident is a bit simpler to build, I think. But from the output you will receive, there's not much difference. I'm not quite sure how much cable we need. Maybe something like that for now. I mean, we can later adjust it a bit still. Okay. Then all good things come in threes, I guess. So this time for sure is the time we get it all right. That was easier upside down. Here we go. I'll just first completely pull that through here. Let's again close one here. That's like secured. But yeah, the reason why I went with a 2.4, and that's not saying it's a good reason, just saying that's my reason, is that I'm thinking about converting this machine into a tool changer. And for the tool changers, if you want to convert it into tool changer, the 2.4 has better options for that. Just like from the way it's built, you can add like different tool heads on front here. And then the printer can move up to take a tool head. And because the Z motion on 2.4 is a lot faster than on the Trident, this is a bit easier on the 2.4, or a bit better on the 2.4. Okay, here we go. I still don't dare to like close all the belt links, the chain links. But technically this should be it. Let's add a little bit more to the umbilical here. And we can pull a little bit more in. Yeah, and this already stands like much nicer upright. Um, Bontek put the index on v0. Yeah, that's I'm actually looking at that. Whether that would be like an option for this machine as well, because like the index, I'm not quite sure what it's called, index. It has one benefit. I lost one chain link somewhere. Here. Has one benefit. It's like if you want to have like multiple tools, like adding a tool is relatively cheap because of their like induction design. So it would be like a nice option. I'm not quite sure if I will go for it in the end or whether I will go with like something like Stealth Changer. But it's definitely an option. Okay, let's quickly add the end stop here. So okay, so the end stop, a bit hard to show everything here. Basically goes in here, and then it's really just like clamped in. They're like two little studs. I can show this close. So they're like two little studs here, and you just press this in. For me, this is incredibly tight, so this is more like a one-time thing, but it just snaps in, and then this is in place. Now I just have to like bend the cables. I want to pay attention to not squeeze the cables here. That looks good. And I think I will replace, oh, sorry, I zoomed in. I will replace this part most likely with a white one. It should be easy enough to swap out. Just like from a visual perspective, I think the white would be nicer here. And this is our end stop. And then on the gantry, let's put this back in. On the gantry side here, so the end stop is not triggered here at the moment. Not sure if you can see that. Like it's just slightly above. So there's another part we have to add, and this is a bit annoying now because this will direct the gantry for us most likely. Maybe we can do it in a way to only loosen one screw at a time. I don't think so. Yeah, so this will definitely direct the gantry. That's a bit annoying because I don't think this holds. Maybe if you're careful, it shouldn't be too bad. So you can adjust it a bit. You'll have it a little bit further out on this side. Yeah. Now it just triggers just like a hair before it connects. Yeah, I think it's still wrecked. We didn't lose it. Also, this part, I think I will reprint in white. Yeah, this is nice. And then I think technically we can finish the umbilical. Then we are done with all the cables on top here. Where's the camera hanging down like that? So for the umbilical, what we need to do, we have to unplug that. For flashing, we need to unplug that. But we can finish the cable. So there's this like part here that holds the cable in place. And this has like two little holes where we have this piano wire that comes with the kit. And the idea is basically that we create a loop here. I think moving the printer out of the way that you can, well, I can do that close up. So we go in the one side and then we just create like a U shape. And push that back out. So this was like quite long now. I think we can just snip that off. Which is easier said than done. Oh no. No! I broke my snips. Okay, this is not easily snippable. Kind of had a... Okay. Very sad. Now I have like a gap here. We have to snip it one more time. That's not good. Tab changer. I was interested by mischanger, but not compatible with BFI, which I have. We'll look at stealth changer, but that is not compatible with that. Well, stealth changer is the second generation tab changer basically. They are like the stealth changer is based on tab changer. It's a newer project basically. Okay, so let's just move that here. There's a screw. Oh, sorry. Oops. There's a screw later here to basically that prevents the cable from slipping out. I'm not going to do that now. So what we're going to do, I'm just undoing the PG7 here. I'm just pushing that through, that we have the same length. We also, it's like I'm not quite sure. Like this will definitely touch the top panel at some point, because this needs to go all the way here. At which point we actually have a little short cable now. Yeah, should just be right. Let me actually, I didn't plug this in properly. Let's plug this in properly for now. Yeah, I want a little bit more. Just pulling out a little bit more cable. So the thing is, now just if I move back, like this will be basically touching the top here. So this is now too tall. I'll leave it now for the beginning. We can always shorten it, but I think this is the length we need as well, because like for the opposite corner, this is kind of like the minimum we can do. Okay, so I'll just cut this here to length. I guess these are ruined anyways, so I go for it. I'm just like trying to weaken it around, and then yeah, you can just break it. So you don't have to press fully, just like carve it in a bit. Okay, then what we gonna do, I'm just using a bit of tape. I hope I have. I have. So it's just like electrical tape. I'm just using at the end of the cable here, tiny bit, just to merge those two together. And we can push this into the connector. And screwed it in. And then this should be good. Now we do have this sleeve here. I feel like the camera always like droops forward. So we can just use the sleeve, but actually let's also push it into the PG7. So this will be too long, which is fine. Oh, let me try to get this started here. Maybe it's easier from the other side. Let me do this from the other side. We don't need that anymore. So let me see if I can. I don't think I can push this over. This is too thick. Nope. But there is this, there's this like rubber thing in there. Oh no, it's down here. There's this like rubber thing. So maybe this is in there. That's unfortunate. I was hoping that we can push the end into the connector here. This, or not connector, in this strain relief. This would look a lot nicer. This is not fun. This is absolutely not fun. I think it's really like, let me see if I can, where are my tweezers? I feel like I just had them. Where are they hiding? Oh, I lost them. No, they're not here. Oh, I put them back. Maybe I can just like try to like kind of like push it in. Yeah, that seems to work, maybe. Yeah, I think that works. So I just squeeze it in here. And now, yep. Can just rotate it in. So now it's actually going all the way down here. So let's see if we can. Here, I have to undo that. No! Ah. Okay, let's try this again. Hi there, Dank. Welcome. And I also pulled out. There's another one of these rubber things. I feel like that should be in here. No, I'm completely destroying it. Maybe that's why they give you two. Let's see. Push this one back in this electrical tape here. I first squeeze that rubber part back into the connector. I keep saying connector, but I mean strain relief. Okay. Length is good. And now let's maneuver the end. I'm not quite sure if I'm doing it wrong, but it's a bit painful. Now I feel like it's not going in at all. For it kind of went in okay. Hmm. Maybe it's because of this rubber thing inside. Let's see. Well, the cable is well protected. That is for sure. Okay, I think I manage. Okay, let's leave it like this. But now if I screw it down, like it twists. And pulls it back out. Ah. Okay, maybe we'll leave that for now. Last attempt. So I really want to have this in there, just like for visual looks. I feel like the PG7 is just like a tiny bit too thin here. Like there's not enough space for everything. Okay, good enough for now. Yeah, I already pulled out. Okay, I'll leave it for now. I'm not having the patience to maneuver that in. Let's just put the sleeving over. This is combined. And then I think we're actually like disconnecting the cable here for now, because I don't want to connect the 24 volt right away. Second, we can also leave it. We just have to add the screw here. And then we don't connect it under deck. Okay, just checking the length. So something like this. Okay, and then we need one screw here. M3 by 8, I assume. Yep. And now this is fully secured. Let's add a zip tie here at the end. Just to keep it neat and tidy. And then this is our umbilical cable. Yeah, like here in the end, like it will definitely like touch the top. For the rest, it won't. Like only here in the back corner, it will definitely touch the top, but it is what it is. Okay, let's close the chain. Yep. And then all the wiring up here is done. The tool head's already fully wired up from our previous stream. Cable chain is there. So that is pretty much it. And we still have a little bit of wire left. Maybe I add this. I was actually thinking of adding a wire like that to the V0 as well. That is just long enough for that. Hi there, Big City Tours. Welcome to the stream. So back to here. Oh, let me quickly sit and recover for a second. Then we need to run some stepper wires. Stepper wires will be fun because they will be quite short. End stop wire should be fine. Oh, this is still the Nevermore we are running here. Having here. This one, let's just say like this is definitely long enough. I don't want to crimp JST, so I will just leave it like it is. We just have to find a way to hide. Like it's literally like it's over a meter left. Quite a long cable, which is great, but you know. Let's see. So the problem will now be that if we want to route these cables like nicely, let me quickly unplug this motor here. Then we can just remove the cables through. if we want to route that nicely, we definitely have to do some magic. I think we need to move the board a little bit this way. That would be the easiest. The only thing we need to consider later on, we will have the screen here on the front. I'm not sure if we installed it today, but there we need a USB cable. And that needs to reach. So this is more or less, we can go a little bit further, but it's a bit awkward position. And I think the HDMI is actually, oh, there was that weird thing, like it points in the wrong direction. I might replace these two cables. Okay, the HDMI is not a problem, the USB kind of is. But let's try to move the board a little bit that way. If you had flipped the controller board, all the cables would have fit. That is an observation I can share. I mean, thank you for doing logic thinking for me, Steve. I'm not quite sure. There was a reason why we oriented it this way, right? Um, let's do it quick and easy. Quick and easy. Oh, yeah, this cable is long enough. We can move it to the other side. So you're telling me if we do it like this, we don't have any problems. And I tend to agree. So let's do it like this, right? And we just have to rerun a couple of cables here. That should not be too bad. Let's just do that quickly. The only thing we need to keep now, more or less, is like the which steppers go where. Let me, yeah, let's quickly pull out all the stepper cables. Right. I mean, better late than never. Okay, that's all the stepper cables out. Then let's do the power cables again. So this one needs to go over here now, which is no problem. We can do that. You know, it will also be nicer for this one to, like, instead of dock here to the side, to be here. Like, if you're already, but this will be impossible to remove. So we'll leave it at. Maybe I have like maybe let's add this one here. Not just too long, seriously. Just quickly snipping off like the last 2 millimeters of that thing. And that's a tiny bit of tape. And then we can add that here is the little extension. Here we go. Okay, then that goes around. That was... Oh wait, that's the wrong cable. You stay out for now. This one goes here. This one goes here. That's a very good idea, Steve. Thank you. This one we can still kind of like keep in here to reduce the length a bit. It's always confusing. Like this one's like half red, half black. Like these two. And these two. Let's put that in the channel here. Okay. Steppers, they don't really matter now, I think. Let's move it out of the way here. So let's just oh, you know what? Now we can also do, I'm not going to move the steppers yet, but I can maybe put the cables in the like the Z0 in the 0 and the 1 in the 1 and so on. This one is 0 and that just fits now. Yeah, that's perfect. Then you are the 2, I think. This is 2. And this is number 3. Perfect. Okay. And then we have A and B. And this channel is now properly filled. I'm not quite sure. This is B. Let's put this here. Yep. And this is A. Ooh. Everything just fits. So the only thing we now need to do is we need to shift the stepper drivers back. So these two need to go out. I regret changing the jumpers right now. Should have added new ones. See that they're in the right spot, although it makes zero difference in which position these two are. Oh. And stepper driver 1 and stepper driver 2. Perfect. Thank you, Steve. That was a brilliant suggestion. That is like, I'm not capable of thinking this obviously up. Okay, so there are two more cables that need to go in this channel, I think, which go here. So this cable here, I really dislike. So firstly, like this needs to go to the power supply. So we need, I want to crimp spade connectors on it. Technically, you can put it in directly. Or is this somewhere else? I don't think we have anything we can do there. No, I don't think there's any connector on the main board. Let's quickly leave this on the side. We have to like, I most likely will cut this cable, recrimp the JST, and just have its proper length. Also, so again, you didn't put a jumper on the motor 3 for the driver. What? Yes, you're right, Steve. I didn't put a jumper there. I'm missing a jumper. I am missing a jumper. Thank you. That would have been a bit painful to troubleshoot, most likely. Here we go. Okay, maybe you can now follow the Voron wiring diagram for the steppers. I think I did. Not quite sure, but now it's back in. Sorry, I was so focused on rewiring, I didn't see the messages. I should probably trim my cables, some of my cables completely circle raceway twice because they're so long. Yeah, I mean, like some of these stepper cables are like way too long now. But it is what it is. This should go here to the side. This also should come in from the side here. Yeah, no, I think the layout's now quite good. Like everything has like quite a good length of cable. The only thing is like we have these like some cables like flying under the power supply here from the stepper here on the back, but yeah, it's okay. Nobody sees that. Okay, where were we? So this cable. Let's actually quickly check. I mean, this wiring guide here doesn't have that at all. So we can check here. And yeah, they see here it's just like 24-volt power in. But they don't really specify where to connect that. Um, and to be honest, like I would not connect these cables directly to 24 volt. Firstly, they are relatively short. Secondly, they are with soldering tin covered. And if you have the soldering tin on the connectors, the connector can get warm when power flows through. I don't think this will happen here like technically, but it could. And the tin will deform and the cable can become loose. So I will just shorten that. Let's do the following. Let's do the following. So I remove the heat shrink here. Maybe camera focus here. So I remove the heat shrink. If the heat shrink wants to be removed. And then what we do, I leave a bit of cable length here in case we have to pull a little bit more. Like I leave like 20 centimeters, 15. And then I carefully make a cut here. I don't think we can pull this in one go. Let's just try like a short piece. So I make a cut in the isolation. So you only want to cut the outer isolation. You can also use a knife. I'm using these pliers now. Be careful to not damage the cables. Try to do it slow, and then you can bend it, and you can see like how it splits open. And I'm just gonna use snips to go under the isolation, and then we should be able to kind of peel that off. So a bit of a process. You can use a knife, it will be easier, but then I'm just like, I don't want to damage the cables. And then, yeah, you can just pull it, basically, once you have the cut. So that works. Where did I start? Okay, so also here, I just bend to open it. Open a little bit here. Okay, and then just going in there. So you're just trying to get started with the cut, basically. And you can grip it on the other side. That's not enough yet. Just be careful to not damage the cable. And then once you have that, you can here you go. That is quite the length to do that though. And at some point, we will be at the end. Ah, it's a full workout. Here we go. Now we have the isolation gone. And the canvas wire, the yellow and the green one, we can just leave. Like, it's extremely long, but it's a short wire, like a thin wire. It doesn't really matter. They are twisted properly, so I would just not touch that. Here we go. Oh. So we now have a little bit of isolated wire here, and then a very long canvas wire. We need to quickly check. I think it's one of these is the canvas connection. So I would just go in here now. Move this over here. Like this. And then the canvas, man, it's super long. We just leave. And the power we can run the whole circus more or less until we come out here. And here we now can connect that to the power supply. So I'll just give it a little bit extra and snip them. Then we do these in a second. And it's this one. My layout looks a little bit different than what they have. Yeah, this looks a little bit different for me, but this one is labeled CAN. So we'll just wrap the cable up here, like just run it up and down this cable channel. And this goes here. Perfect. This fits, that's good. Then let's crimp these cables here. I'm quickly just removing. Oh, oops. Okay, that dropped into the power supply, doesn't matter. Will come out eventually. Then see, again, like we need these connectors, all these crimps. I think it's really good to just have these at hand. Like you will need them. And then you can also do the Wago very easily because you have them already. Here we go. Just make sure you see the cable peeking out at the front. It's probably in. Two. And then we can connect them. So we have like plenty of free terminals here. We just choose any of the plus, any of the minus. That actually ended up being hair long. Let's just fold it back into the channel. Then we just push it in here. Perfect. Then Nevermore. We have a Nevermore. Let's put a Nevermore in. This is so weird. Like, this does not really fit at all what I see here. So the Nevermore, they crimped on a JST with 3 pins. But what they show me here, I wonder if this is the old version of the board. I wonder if this is the old version of the board that they show here. So either way, we have to run this over here. Let's just put it out here for now. What are you? Oh, wait. Oh, this is the... I mixed up the cables. Stupid me. This is the Y and stop. It's also fine here, but let's actually take the Nevermore cable. They don't specify which one of these fan ports the Nevermore is supposed to be, so I'll just pick any, and then we have to just figure this out in the config as always. Y and stop. Also this one, I'm not quite sure. They put it on the second one. Let's also put it on the second one. Can you please stay in the cable channel? Thank you. So this goes here. That also stays in there. And then I think we have all the cables that need to be cabled are cabled. That should be it already. Minus the screen, which I really wouldn't connect now, but that should be quite an easy run now, because we can basically have this here. I mean, now I kind of put the cables in already, but like we can control the length here a bit, so we can store the cable in this. Oh, you don't see that. We can store the cable here in this channel. Same for the USB, we can either here or here, just like store the cable. Then let's quickly close up the channels, because there's no more cable to be cabled. So this is the short one. You are this one. You are this one. Yep. This is this one. This one is pretty much empty, but actually by now we could have also run this cable most likely this way around. But then it's mixed up here with the AC, so I think this is a better thing to put it under the power supply here. And that is it. I think this is actually like a very cleanly wired build. See if we can find like a little bit of leftover for this one. snip that here, snip that. Just for visual completeness. That would be like a skirt holding it in. Cool. That's everything wired up. Oh, the bed. We're missing the bed. Let's. Ah. Oh, hi there, everyone. Sorry, I'm completely distracted today. I'm missing all the chat messages. I'm so sorry. Not as hard to configure, but easier to maintain and troubleshoot when something goes wrong. Yeah, that's absolutely true. And I did not put the 120, the jumper for the 120 resistor yet, Steve. But I'm also not quite. Oh yeah, here it's labeled 120. So let me just quickly put that. It looks like a small. It comes with like large and small jumpers. This one looks small. Nope, there we go. 120 resistor goes here. Which is actually not marked in their wiring thingy. Then yeah, the bed. Let's mount the bed. And then we have to open 2 cable channels again, unfortunately, but it is what it is. Oh, I keep forgetting this. The transparent cover for the power supply terminals here. There we go. Up. Let me. Oh, this stepper is now very hard to move. Which is not a good sign. I unplugged the stepper. That's a bit concerning. Also see now that we have quite a bit of cable loop here. So maybe we want to pull that down a little bit more. Bit more than I like. Just a bit more. Yes, but first let's do the bat. Which we have here. Starts looking like a printer that could be printing. I assume the wires need to go through the same hole. Let me check the manual. But that's manual like way before. I think there's VCC if there's no jumper added on the fans. Anyways, yeah, most likely. I mean, they didn't have anything here with jumpers at all. Like looking at that. No, see here, they don't have any jumpers. But then there's also like a slightly different board than what I have. So I think we should check the MAP manual in a second for that stuff. Let's see. Here's bad. We did that. We did that. We did that. So M3 T-nuts. Then we have these other thingies as spacers. And then we have M316 socket heads. Yeah, that looks good. Ah, and the wires go through the same hole. So that's now like something we should have, I think we should have done that before starting the wiring, because now it will be a bit painful to push those wires through there. Um, that will be a bit painful. Let's quickly flip it over again and remove the cover of the cable. I'll also quickly turn on my music again. Yeah. I think I just made a huge scratch on my table. Confirmed. Ah, shit. I added these like rubber felt thingies to prevent that. Ah. Oh, actually, I was lucky. I was lucky. Oh. Okay. Um, yeah, there's like the aluminium extrusions on the top are quite sharp on the corners. So I added like these felt gliders. Ah, come on. Instant regret. Oh, maybe. Let's just pull it out, maybe. That would be easier. Okay, so we kind of have to shove a lot of cables through this very small hole here. I did not consider that all the bad cables need to go through here. So this will be a bit of a challenge, but it will work. The only thing... No, it should work. Okay, let's mount the bat. I just want to make space here that we can like push the cable through, which we can now. So I think we should have mounted the bat ever so slightly earlier. We have M3 peanuts. And we have the M3. I also still not caught up on messages. Ravonic, haven't joined the stream in a while. I've missed the whole 2.4 build. Well, you are here for the most important part. Although, like, looking at the time, I'm not sure if we will make it for the first sprint. Also, like Steve said, the fourth connector from the stepper on the mainboard should not be used. Why should that not be used? It doesn't really matter which steppers are used, right? Or which driver slots. Oh, we also need these like isolation thingies. Okay. Quickly move this here. Here they are. So the Formbot kit comes with these isolation columns, they call it. So I think we should first do the cables and then work on the mounting. third and fourth are connected. It's 3A, 3B, 4. Oh, you mean that there's a connector that's like two connectors for one separate. Okay, let's quickly check that. That's a good one. Okay, let me. In retrospect, we should have added a second hole here. So if you do this, I drilled 10 millimeters. I think we should have drilled at least 2 10s next to each other, just to have more space for all these cables. I think it will work, but it would be easier. It would be easier. Also, this cable is a bit of a mystery. How they intended to work. Okay, so all the cables are through except this one. So this one is labeled 2 SSR, and this is labeled frame. The problem now is that this definitely does not go far enough for our thing. So I think we need to replace this cable. Is the yellow the ground cable? Yes, this is like not protective earth is I think the proper term in English. Which now doesn't come back out. Shit. Okay, we have to redo this cable anyway, so I'm not gonna waste a lot of time. I just have to unscrew that screw here. Okay. So I just removed the cable here from the bed. And I just destroyed this cable. So we need a new cable here, obviously. Let me quickly make some space. LDO kits really look to be premium. Yeah, that's the thing, right? I mean, you pay what you get for in a certain sense, but I don't mind the little bit of extra legwork. I also enjoy it in a certain sense. I really have to like place the camera somewhere else. Like this is kind of like always behind the printer. I have a Seaboard and it's been fine. Yeah, I think the Seaboard is like the middle option. Okay. So I'm not quite sure where they want to connect that to the frame. Oh, you see here? That's where they connect that. So it's just on the side. So let's just do that from the Wago. So that means for me, I just need to make one cable now. With the O. And I'll just generously cut that. And then I make a very short second one. You know what? Maybe we can also... No, we can't do it. Just a very, very short one. We use the same loop thingy. Frame is anodized, so it doesn't connect mine. Yeah, that's also what I know. Like, it won't do anything. So Technically you can leave it out, but let's do it properly. I mean, you can technically like scrape away the anodization on one spot, but then it won't connect to the next. So it's a bit of like, this only makes sense if you have like a bare aluminum frame. I mean, maybe if there's like a very high like power on it, maybe it connects. I don't know. Um, let's just stuff that cable through here. I have to add the screw back here. I mean, grounding the bed definitely 100,000% makes sense. Yeah. Can I manage? So this one here is important. The frame is like, meh, I don't know. Pull all the cables through. Okay, then let's quickly mount the bed, and then we can flip it back over. Let's do just one as reference. Then oh, I have this one here facing the front. I'm not happy with this. Can I get this out? These were like the painful ones to get out. I don't think I can easily. So this is like facing forward, but then you can see it peeking out. I don't like that. Let me see if I can quickly. I really hate removing these. Yeah, okay. Went quite well. Let's flip this over. There we go. Let's just move both of them to the front, and we can do the front too. Okay, so these two are in. Turn it around. Oh, I should have moved them further back. Let's just try to have them like somewhat on the same height. Hey there, Jonas, welcome. LAO kits are really well thought out. I only have experience with 2.4 LEO and the Formbot 0.2 and now Formbot Micron. Oh, very nice. How far is the Micron along? And the LEO kit has better hardware, better washers, better docks. Yeah, it's exactly my experience. Nope. It's like the LEO is like really like, it's easier to build. It's well better documented. Also, like, yeah, like you say, the hardware is nicer. It's like very small detail, right? Like screw. But like they just look nicer finished. And for me, like the one big plus really is like the documentation is better. Okay, we can always change the bed position a bit, so I'm not really like going crazy over that now. I'm trying to pull the cables through properly. Okay, and this looks more or less center. So that is mounted. Quick and easy. Now it will be like 5 times the weight. Can confirm. Yep. And I'm still a bit scared to scratch my table. Okay, before we forget the very important earthing of or grounding of the frame, let's quickly do that. So we just go in here. We can also just do it here on the side. Oh, conveniently, there's M3 T-nuts in here. Side. I pushed like 2 M3 T-nuts in there, and now I totally forgot. Let's actually see if we can quickly get one out, but it will be a bit. No, they're there to stay. Okay, let's use one of them. I have M3 4mm button head here, which is perfect. So I will just use one of the two we accidentally put in there. I need a Allen key for that. No, but I don't have an Allen key that size with a. I do. We have to open this anyways. Let's quickly open this. Not sure if this will be a success. Yeah, I think now it's in. Here we go. So frame is grounded. I don't think this will not do anything because of the anodization, but we are fulfilling the requirement. So this is shortly look here. Then the last cables that we gleefully forgot. Let me see. I'm kind of considering. Yeah, we should run it like on the front here. So let's. This like T intersection here is like incredibly stuffed with like stepper cables. Okay, looks good. Let's push this properly in. Here we go. And then we can cut that. will come out eventually. And check. This is done. Then what do we have here? This is the thermistor for the bat, the red wires. Let's should kind of sort these cables a bit. The thermistor needs to go to the other side. Which one are you? Let's quickly check the thermistor bed is here, THP. There we go. Yes. This one. So then yeah, for the fan jumper. I mean, let's just add a jumper here, but they don't have anything on their manual. You will need to adjust the bed with the tool head since you're using tap, and you'll need not scrubber. Yeah, that's for later. Like we can always like the bed like adjusting is super easy. The only thing, and you're absolutely right about that, we should leave a tiny bit of extra wire under the bed that we are able to adjust it a bit forward, backward. So let's not pull the cable completely in. I'm just leaving like a tiny bit of cable under the bed. Just like extra 2 centimeter. And we can move it. Yeah, check. Okay, then 2 wires left. Oh, no, I pulled it, pulled it out again. So, this one goes to neutral, and this one goes to the solid state. So both of them need to first go here. Now we do mix the AC and DC wires a bit, but I think it's fine. Okay. Let me see. This one actually has a perfect length, which is very nice to see. So this one goes here. And then this one needs to go to neutral. So this needs to go here, to the blue ones. I don't like that this is not blue. Let's check one thing. I have heat shrink. I'm fairly certain I have blue heat shrink. Yes. So what I will do is like I have a little bit of blue heat shrink here. Oh, we should have also maybe kept the label on. It works. Ah, maybe it doesn't work. Okay. Um, we add a blue heat shrink here to the end, just to signalize that this is blue. Yeah, I still prefer the entire cable to be blue, but this is as good as it gets, I guess. You know, managed to put us in here. Here we go. So at least like it has a little blue signifier here. But yeah, like the sleeve cables, not a fan for AC. Now we're done with cabling. Will I regret closing the cable channels? Maybe. So, and we also need to quickly check these stepper things here. So one of them we should not use. That's what I heard. Oh yeah, don't forget the stepper connectors. Yep, I did not forget the stepper connectors. So we have them slightly different. So they have 1, 2, 3, and then this one. So this one. Yep, come on. Needs to move one over. That's what I hear. This one needs to move one over. I'm just not sure because this is like a slightly different board. Maybe let's quickly check the proper board documentation. What they say. Yeah, it's motor 1, 2, 3, 1 empty, 4, 5. 1, 2, 3, 1 empty, 4, 5. 6. Yeah, okay. Then it's not correct. Now we just have to convince all these cables back in here. Maybe that's why one stepper was like very hard to move. Okay. Perfect. Well, it's like really, really clean wiring now, I think. Like there's really like no random cables except for here, but I guess you cannot really prevent that. But everything else is like very nice, straight cable run. Perfect. That's why I pull on that. Let's recrimp this one. I always do the tuck test. Exactly for this reason. Because I'd rather find out now that they're not properly crimped than later. Let's try this one again. Perfect. Okay. Good, we tested. Before I forget it for the 50th time, let's add this little cover. And I think really then the wiring is complete. Yeah, now that the weird motor is gone. So it was definitely because like two were plugged into one. Yeah, technically we can turn it on, right? No more cables left. Oh, the only thing we have left is the air filter cable. But we're not going to do that for a second, so we don't have to worry about that. Well, then let me quickly like do like a very brief like a cleanup here, just to get rid of all the things we don't need anymore. And oh, there's one thing. Oh, but this is brilliant. Ooh, lucky me. Steve, thank you for suggesting to flip the board around. I think with the other side it would have been like more painful. Will it be magic smoke or not? I don't feel like a lot of confidence in my work. I'm very sad now. Yeah, let's leave it upside down. There's one thing I said we don't want to do, what we actually did now. And that is we connected the tool head 24 volt. I want to keep that off for now because we need to flash. And for flashing, I don't want it to be connected. So that should be this cable here, I hope. So I will remove this cable here. Just had electrical tape in my hand. And then what I always do, I mean, it's kind of optional, but I guess I recommend it. I can't say it saved my life completely like once before, but it doesn't hurt. So if you have a multimeter, like simple multimeter like this, just do yourself a favor, go to the mode where it beeps when you connect it. Like now it beeps when I connect these two. And then we can just do like a very quick run through. So we don't want to have a short on plus and minus, which we don't. Success, great. And I also ideally, let me see where I can probe that. I probe it just here on the back. So the left and right connector. I definitely don't want to have a short. Make sure to turn it on maybe. So there's no short. Double check. There's no short to ground on either. So we know that the AC are separate. We know that the plus and minus are separate. So we are golden. Let's also quick check that Earth is connected here. That means it's connected there. And here. Also, like as a fun side story, like I'm not connecting, like this is not conductive because the anodization is what we had before. This one should be ground Earth. The heat bed should be, it's also connected. Yeah, should be fine. So also quickly, I mean, we already know that this is not connected, but I'm just like cautious. Yep, that is what I want to do. Just like quick check, just prevents not all accidents, but some accidents. I'm more confident in you than in what I would do. You know what? I was actually thinking of your mini switchwire earlier in the stream, because we did this protective earth thingy here with the frame. And I know you didn't use anodized aluminum extrusions, so you should definitely do that. Because for you, it actually does something. For me, because anodized, like this is more or less isolated, but because you have the bare aluminum, you will have like the frame being conductive. Um, we are making a 3D printer that can print Peak, and we are using a Trident as a platform. Just tells how much the Voron team is sound. Yeah, definitely. I think it's really cool machines. They're very simple in a certain sense. Don't use any fancy parts. It's really nice machines. I like them. Well, I don't think there's much I can do besides turning it on. Before we do that though, so I have the switch off here. There's one more thing. Maybe you have spotted it, but down here on my table, I have a SD card. And this is pre-flashed with the latest CB1 firmware. So you can just go to the GitHub of the CB1, download the latest firmware. They have instructions on how to set up your Wi-Fi. So this already should connect to my Wi-Fi. Speaking of which, we did not connect the Wi-Fi antenna yet. So it's also something you should do. So I just popped it in here. Fun side story. So on my switch wire, I have the M4P, same thing with the SD card here. And it's absolute pain to get to that because like this far off the extrusion. So I was like using like tweezers from the top to kind of like inch it out and like get it around the corner, and then I had it out. And then I had to put in a fresh one, and man, that was even worse. Like putting it back in. The other thing is the Wi-Fi antenna, which I know I put somewhere. And I put it back. Let's find a spot for this one. So, I mean, technically we don't have to glue it down. We just have to put it on here. Like there's this like very tiny connector here. Um, technically we can just put it here or somewhere. Doesn't really matter. You know what? How about we just put it here? Then it's like a bit separate from everything. I feel like that's a good idea. There's our antenna. It should be quite a good spot. I only peeled half, then you can like pull off again. I learned it the hard way. Like in my switch wire, I put both parts down. It's like impossible to remove the antenna again. So this one is not stuck. And I don't put it in the cable channel just on purpose to have it a little bit more separate from the other cables. I'm not quite sure if that does something or not, but I feel like it's good. The fans is also missing the jumper still. Let's just put it. I know they don't have it in theirs, but let's just put it on the V-in. Because, and before I do that, let me actually double check. Yeah, the fans they give me at least, are 24 volt. Oh yeah, that's per fan. I see now. Okay, then let's not do that. Then you can switch it per fan, which is very nice. Cool. Well, I don't think I can do anything to make it go away, so that might be a good point. I didn't really check, but we'll fix it when I get to that. Yeah, definitely do that. You know, just doesn't hurt. It's off. Steve didn't tell me I forgot something, so I think I didn't forget anything. We double checked. I'm low-key nervous, but here goes nothing. I think we survived. We have 12 volt, 5 volt, and 3.3 volt. Nice. There's a green LED here from the power supply. This one is isolated. That is good. It means technically the CB1 should be booting. I don't see any LEDs there, to be honest, but I'm not sure if there's a power LED on a CB1. Like, not saying that it's not that's there and not on. It's just saying I'm not sure if there is one in general. No, I don't think there are any LEDs on that. Okay. Um, let's see if we find it on the network. Let me move that over. Oh, man, I was like constantly like standing on the on my tips on the tips of my toes, and my feet are absolutely baked. Ah. Yeah, now I need to remember how I called that thing. Let me quickly check out my router's UI. Um, I don't see it yet. No. There's one thing I don't know what it is, but it's on the wrong Wi-Fi network. Not it, not it. That's not it, not it, not it. Let me see. I just really don't remember what host name I gave the thing. No, it's not here. Question is, should there be any LED? It's not described. So here's the LEDs you can see on the side here. And I don't see any other LEDs. There's one LED, I think, here, like a small one. Next to the CB1 should be green LEDs. Yeah, there's a LED here in the corner, and it's definitely not green. Oh, but there's a green LED on the CB1. Like you can, I'm not sure if I can show you that. Maybe we just need to wait a second. Can I show? That's very hard to show. I think you have to trust me. I think you have to trust me that there's a green LD under the heatsink. So I think we just need to wait for the first boot. That might take a hot second. Should be flashing as it accesses the SD card. Let's just wait like 3-4 minutes. Like there's definitely power on the CB1. Oh my god. There are 2 SD card slots. I know what's happening. I put the SD card in the wrong SD card slot. Where does it describe that? Here. Yeah, I did that all. I did that. But does it say where to insert the SD card? No, it doesn't. So the thing is, there's one SD card slot here at the end, like here, and there's one here, and I think it's this one. No, don't use pliers for SD cards. Let me quickly cut power. The SD card is, I'm very certain it's the SD card slot here. Man, that's a stupid design. Yeah, that's exactly how I thought this would go. Yeah, see, there's like two SD card slots. On the M4P, it's better because on the M4P they have a micro SD card slot and a like full size SD card slot. So it's two different, and one is for the mainboard and one is for the CB1, and the full size is for the CB1 and for the mainboard. Okay, second attempt. I have the same green LED on the under the heatsink. Ah, yay! And now there's also green LED here on the corner. Yeah, so lesson learned, it's this SD card slot, but I don't describe it in the manual. Like seriously, it's like here it doesn't specify, right? It doesn't say. And here it also doesn't say because it doesn't look at the other side. I mean, maybe it's the picture that doesn't load. Who knows? Okay, let me peek in my router again. There it is. There it is. There it is. And we have a ping. And yes, the printer is called Claire. All my printers have names with C for, I don't know actually why I started doing that, but that's how it is. That's SSH in. I think it's bq at claire.local and the password is bq. Don't disappoint me. Yeah. So bq. I remember correctly. Cool. Yeah, this is welcome to the CB1. Everything is more or less installed. Like I used the, they provide different images. Let me quickly show you. They provide different images. BTTs, CB1, GitHub. They provide different images. So it's a V300 that I now use. And I use the Clipper image, basically. Reason is that you don't have to install everything. It's just there. I think it's technically maybe better to do it yourself than you know what you did, but the other thing is I think Canvas is also already there. Let's quickly check. So I have the manual. I linked that. Oh, but I closed it again. Ah, no, yeah. So I linked it in the YouTube description. So it's in the description below the video. Somebody made this guide for exactly setup we have. So it's like the Manta M8P with the EBB 2209. So this works for us. We will follow that. There are two things we need to pay attention to. He uses the MAP 1.1. We use the 2.0, so there's the configuration slightly different, and the EBB 2209 most likely is also like a different model. But we will just follow this, and yeah, let's see. And yes, Alex, second boot. So Catapult is already there. So I'll just stay here in terminal. You have the thingy on the side. No Catapult. Oh, that's sad. Can we install it via Kiao? Yeah, let's update. Options branch. Migrate, yes. Migrate. Do your thing. Install. Yeah, we also have to update Clipper. I just look for Catapult first. I'm not quite sure if we can install it via Kiao. Extensions, maybe? Main thing. Simply print. Wait, we used the new Kiao, right? There was like this question about new old. No, they don't do that anymore. Okay, then let's clone that manually. Let's clone that manually. Catapult GitHub. Yes, grab the URL. Git clone. Let's try again. Here we go. Okay, perfect. Let's quickly check in the Big Tree Tag documentation the proper configuration for that. Do they have that here? Doesn't seem like it. They have the view update. Configure Clipper. Oh, here they have it. So we have STM32 and STM32H723. H2723 it was, right? 723 it is. 128 bootloader. I think this is the offset here. Yes, and then clock reference is 25. And communication interface, we need to quickly check the other one. Communication interface exactly is CAN bus. On PD12, PD13. The question is now, is this the same? I hope it's the same. And canvas speed 2500 seems not correct. I think we want 100,000. Then enable bootloader entry to rapid, I guess. Yeah, that is there. So let's double check. We have the correct chip. We have do not build. That also was in the other one. We have 25 megahertz crystal. We have the PD12, PD13, 128 kilo. Boot. USB to CAN for Catapult? What do you mean? like, so basically what we're doing now is like we configure the M8P to be connected via CAN bus, and then it will act as a CAN bus bridge. So this also will connect over CAN bus. But let me quickly double check that M8P CAN bus, M8P 2.0 CAN bus interface. Just to double check that we have the right pins here. We have another YouTube thingy, amazing. But I saw that. Exactly, there's this document here. We have a screenshot here. Yeah, PD12, PD13, and he has the same board that we also have. Yeah, so it's PD12, PD13 is correct. But he has a clock reference 8 megahertz crystal. So I'm not quite sure. USB for Catapult and USB bridge for Clipper. Are you sure? Because everyone else does CAN bus here. Oh, you mean USB CAN bus bridge? Yeah. But Catapult is also CAN bus. The only thing that confuses me is the 8 megahertz crystal. Let me quickly check. So M8PV2.0. Clipper flash. I don't know. Because he also has the 25, but he says it doesn't work. Yeah, so I think we go with 25 megahertz reference. Let's just roll with that. Okay, then escape. Yes. Then we need to say make. And then let's go back to our reference here. Have you looked at Esoterical Canvas Guide? Yeah, the thing is just like this one is specifically for what we want, so I figured it's easiest to just follow this one. He also references the Esoterical. Like this is, he basically copied it out more or less. Okay, then we have CAN boot pin and Catapult pin. Then we go to Clipper. As who said to update Clipper? Somebody said to update Clipper. Don't see it anymore, but we just do git pull, so now we have the latest Clipper. We say make menu config. We go for the STM32, then we have this STMH2713. We have the bootloader. Communication is CAN bus bridge. And the CAN bus interface is again PD12, PD13. And I'm missing like a couple of settings. Oh, we need the extra loader thing here. CAN bus is that. And the clock reference is 25. Oh, he also has 8 here. I'm getting really like mixed signals here. I kind of want to trust the official documentation with the clock reference, so I think I'll stick with that. But I think that we have everything here we need. 8 is the Manta V1. Yeah, I think the V2 has a much faster chip. Yeah, the guys for 1.1, yeah. but also he is using 8, which then makes me wonder if this is because he has the Pro Plus kit, and this is like the V2, I think. At least it looks like that. This looks exactly like my board. No, this is also the 1.1 because he has 2 of these. Um, but then I'm not sure. Um, let's quickly check the GitHub of the BTT Manta M8P GitHub. They have for sure a GitHub. Yeah, the wiki links back. Aha, for the resources, consult that. Okay, whatever. Let's check that. Where's the user manual? Let's quickly see. Well, this looks very similar to what we have on the web page, but oh no, it's definitely more detailed. Let me quickly download that. So let's quickly scroll through if we see any clipper here. This is with USB. And that's it. They don't describe that at all. I don't see that. It's 25, yeah. I'm sure it's 25. Yeah, okay. Maybe let's quickly check esoterical after all. Mainboard. We have catapult. We have that. But I'm just not sure, like, where to get this communication interface from. Does it somebody know? Yeah, I'm on esoterical. But does it have the mainboard? Because what I need is like this value. And let's just roll with the same as they have, PD12, PD13. But like, if somebody can tell me where to get this from, because usually it was like I always found it like in the documentation of the board. I find it in Discord. Where in Discord do I find that, Steve? Ah, thank you, Steve. Let's quickly see. Gettable config. So here's USB. You know, it's like it's not really helpful that every guide has something else. But let's go with that then. Let's do that then. So also here it now says this. I'm very confused. Communication interface is USB. We have 128 kilobyte offset USB IDs is empty. Support bootloader entry is a check and enable status LD is a check. Okay. Then we save, make clean, make. Oops, let's go to Clipper, make clean, make menu config. Let's try this again. So we are STM32, we are STM32H723, we have a bootloader. The bootloader also looks a bit different for me, but it's 128 kilobytes, so it doesn't matter. Clock reference 25. Then this is the bridge. Canvas interface PD0. PD0, PD1. And that is it. Yes. Make. Catapult is a bootloader and access the mainboard via USB. Yeah, it's, I don't know, like it's just like in the other guide I was planning to follow. Seemingly now I don't. Here it definitely says communication interface canvas. That's all I know. Let's still like loosely follow that. Like we have like the configuration now. Then this is the same DView mode. I mean, it's also here referenced in the esoterical. Let me quickly close all the things. Yeah, we don't need that. We don't need that. So here it's the 2. We need to reset that. I'm pretty sure that the image the CB1 image comes with CAN already set up. We need to quickly check that. But I put a new SD card in my switchwire, and I didn't have to set up CAN. It's also described here. So let's see. Yeah, it's already done in CB1 image. Yeah. Let's see what the AI says to that. That's not what I wanted. AI is not ready to rule the world. Let's quickly peeling show. What does that do? I'm pretty sure it just works. But there is no canvas indeed. So let's see. But then we are ready for DView mode. Let's just follow the guide here. So we say boot 0 reset. Ugh. Let me get 2 things to poke. So we have boot 0 reset release. Should have said. And then release reset, and then boot 0. And now we should be in DView mode. Let's check that. Yes, we have one entry in DView mode, which is exactly the STM device we are looking for, which is amazing. So something works for a change. Let's flash catapult. Let's double check. This is the right ID. The ID matches here. So let's flash that. BQ. Yeah, and this is the typical thingy. It says file download successful and an error during download get status. That is the expected nonsense. Then reset the board by pressing reset and then put the board in the view mode once again. Let's press reset, and then we say boot 0 reset. Herrgott. Yeah. Boot 0 reset, reset, boot 0. There we go. Then we should be back in the view mode. Let's check. Yes, and then we can flash Clipper. This one is success for whatever reason. Now the board should be running Catapult with Clipper. Verify by pressing reset once again, then run LSUSB. I'm pressing reset once again. Then I run LSUSB. Well, it's not here. What should we see? The board should be identified by bus 0 device 11 open Moco Schneider CAN adapter. I don't see that. I don't see a CAN adapter. That's sad. I also don't have this device. Let me quickly reset again, just to be sure. Nope. Let's quickly scroll up. What did we see before? Yeah, we had 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Yeah, that's exactly what we see now here as well. So like the device is not here. Very sad. What did we do wrong? What did we do wrong? Let's quickly check the catapult and Clipper menu config. So we have STM32H73, we have the build catapult deployment application, clock reference, USB, application starter set 128. Tap reset twice. Let's tap reset twice. Nope. Nope. I mean, the only difference I see is the bootloader offset on the esoterical is like 128 kilobyte bootloader, and it says SKR SEBXV2, and mine does not say that, I think. So in Catapult, it says that build Catapult deployment application with this one, and then it has application start offset 128. That looks all. This was missing the PC3. I'm not quite sure what that does, but yes, make clean make. So there was a small difference here with the PC3 missing, but I guess then it just doesn't do anything. And even if Clipper didn't work, I think at least Catapult should have shown up the thing. Yeah, that will give you a flashing LD when you double tap reset. I mean, some visual feedback is nice. So let's try. Yeah, it's LD flashing. It's just like because I didn't configure it correctly, maybe it does something weird. Mm. See here, this one is different for me. Like, might just be difference in Clipper version. But I did pull the latest Clipper. It's SDMH. Yeah, so this bootloader offset option here, like it looks different for me, but yeah, it's most like just a Clipper difference. 25, USB to CAN, PA11, PA12. And then we have PD0, PD1. And then we have 100,000. So this looks all identical to me. This looks all identical to me. Yes, safe configurations. Let's do the following. Let's just reflash quickly and see if that does something. And we also use tweezers. So I will press boot 0, boot 0, reset, release boot 0. Now we should see it in the view mode. Yeah, it's back in the view mode. Then we say flash catapult, please. Yeah, the error as usual is normal, like this is the important part. Then let's press reset. Then let's press boot 0, reset, release boot 0. Now we should be back in the view mode. Yes, it's back in the view mode. So let's flash Clipper. Oh, we did not make Clipper. Nope, we did not make Clipper. My bad. You have your clock set at 8, not at 25. What? Make menu config. Yes, Steve. Ah, thank you. Yes. Make clean. Make. That is most likely it. But I'm curious, like the M8P has like a much faster chip than any other mainboard I've ever had. Like the SCM controller on there is like blazing fast, like 500 megahertz or something. I really wonder if that makes a difference. Like maybe if you like really push for performance, like maybe it does, but I'm not sure if it's like in daily life, let's say, there's any difference. I also have to reflash Clipper on the M4P, but M4P has not doesn't have the view mode, which is like incredibly annoying. Okay, file download successfully. Let's reset. Same. I don't see it. Nope. Um, let's double check. So now we have 25 here, bootloader. B12. I don't see any difference. Yeah, I think it doesn't make any difference, like unless you really push for like the absolute highest performance. But right now I would be happy with anything working. PA11, PA12, application 128 offset. Yeah, unless I missed something else. But do you think, but even, Steve, the thing is like even without CAN network, right? Like we are looking at the USB devices here. We are looking for the CAN adapter. Just CAN boot? And we can try that. I don't think that makes a difference, but ls USB. Yeah, it's back in DView mode. Let's flash CAN boot. So now it's still in DView mode. No, it's not in DView mode anymore. It reset automatically. We now have open Moco. This is the board. So this is now the CAN bus adapter. Now it's here. Yeah, that was a good one. So this one is here. Reset twice. Like twice fast. 1, 2. It's like resetting. Yeah, I'm pretty sure it's a problem with Clipper. But also like the reset twice. Oh, now it's blinking. So now I have a red LED blinking here. That's what we wanted to see, right? Oops. Oh, I can. This is what we want. Flashing LD. And now I flash Clipper, you say? But with this command, right? With dview util. No, you don't see it. Sorry. With this command. Waiting like 3 more seconds for confirmation, and then I'll just run it. All right, let's go. Yeah, exactly. But now it says there's no dview. There's no dview device because it's not in dview mode. Let's quickly check the esoterical guide. Uh, what does it say? But how do I now flash Clipper via CAN boot? That's my question now, I think. I need to use the catapult. I need to use the catapult. Exactly. They have the flash tool. Sudo service Clipper stop. And then ls-def for serial. Okay. Yeah. Okay. Yeah, we have a catapult. And then I can use the catapult flash tool, I guess. But I don't have a UUID. I'm kind of missing, like, what am I doing wrong right now? Where do I get the UUID from? Because I assume this is not a command I need to use the flash tool. I'm not sure. So, well, if everything is an esoteric can guide, it's nice, but I'm kind of like missing the steps. Like my brain is also completely fried at this point. Steve, can you maybe send me the link to the steps? Like there must be like a web page with steps, and I'm kind of missing it completely at the moment. And to be honest, my brain is like absolutely done for today. So maybe it's also a good point to just like stop and try again tomorrow. So we have catapult. We did the view util. We do LSF for serial USB scripts. Um, okay. This is the command I was missing. Okay. Here we go. Um, oh, Python. Okay, whatever. Let's install it. Yeah, see if I found the page now as well. That didn't seem clickable to me. Let's see. Okay, so this is installed. Now it's flashing. Okay. Then, we run that. Clipper's now installed. So LSUSB, LSUSB. Yes, now we have the CAN adapter. Check. Okay. Then check this. We have a CAN bus interface. Great. The QLAN is 1024 for me. And the bitrate is 100,000. I'm not sure if this is a problem. Does it say that? It doesn't specify. I assume it should be fine. Let's do the query can, but I think then this one is good to go. Yeah, so we have one working one. Check. Whew, okay. Yeah. Sorry, my brain is a bit lacking. let's try to flash the board, the 2 board. I do need a USB cable though. Which I'm not sure if I actually have one here. I don't think I thought so far. I have a couple here. See if we have one that is long enough. This looks like a, yeah, this one is it. So, I think we need to quickly flip over the printer because we need to go to the tool hat and we need to most likely add a jumper there. I'm not quite sure if we added the USB power jumper. Oh, yep, I just plugged it in. And let's flip over. Oh, printer. Whew. Yeah, it is getting heavy. Okay. I did. I also remember doing it. Yes, I did. So this is all fine, like the 24 volt is not connected. So I think we can just, we have to unscrew that though. It's not connected, we still have to unscrew it. And then this is just a cable that runs to the main board. And we do have LEDs here. Show that, but there's like green LEDs. So back to terminal. LS USB. And yes, we have the RP2040 here. Tool board flashing. So we have catapult, that's already there. Then we need to configure this. Common tool boards. I'm getting the hang of that guide now. 2209. So catapult, make menu config. We have RP2040, of course. We have WQ, yes, 16 build catapult deployment, 16 kilobyte bootloader. Communication is canvas. 4, 5. 4, 5. 100,000. Check. And this is GPIO 26. GPIO 26. And quickly double check. Yep. Yes, we save. Make clean make. Let's also do the clipper right away. It's not an EBB36, it's names. SB209. Yeah. Oops. Clipper. So we have RP2040. We have 16 canvas. 16 canvas. 4, 5. 100,000. And this is GPIO 26. Check. Okay. Okay. Yes. Make clean. Make. Okay. Then let's go to flashing toolhead. Then we do ls USB. We have that. Then we do the catapult, make flash. So we check this device ID. That does not match mine. I have a different ID here. Yeah. Oh wait, we need to set in boot mode. I skipped something. Was not mentioned to put it in DView mode, right? To confirm it's in boot mode, run ls USB command. Okay. Well, I guess we have to press the button. What do you mean with it is? I don't see it in boot mode. Why would it be in DView mode? I first have to put it in DView mode, right? Did you do that? Boot, reset, reset, boot. Now it's in boot mode. But I'm either too stupid to see where, but doesn't say that explicitly. Here we go. Rebooting device. Um, Shut down your Pi and then power off your entire printer. Take the NED view jumpers off your toolhead. Yeah. Let's do that. Put it in DView mode, yeah. So let's give this all a second to shut down properly. And should be enough. Okay, then let's remove the USB cable. We put back in the campus cable. We also have to remove the jumper, which is actually super important. If you don't remove the jumper, I read you can fry the USB controller with 24 volts. We don't want that. So we need to remove that power jumper here. If it wants to come out. Okay, so that's out. Then we can close this entire thing up. Okay. Um, then we have the fun part of flipping it over again. And now this cable that we put aside, we need to put back. Gotta love electrical tape. That goes here. Okay. And then we can put it back on. I think. We didn't forget anything. We now have power. Nothing exploded. Let me carefully flip it back over. And then we need to quickly wait for that to come back online. Oh, that was quick. Okay. We don't have it here. Let's see what it should do. Yes, we have two. We have Clipper, which is the main board, and Catapult, which is the tooltip board. We already configured Clipper, so we can skip over that. Make clean, make. We stop the Clipper service. Yep, the URLs are here. We can always go back to that. Okay, we query it again. Let's try again. Okay. And then we flash the one with the correct UUID, which is the one with Catapult, not the one with the Clipper already on there. Which one you know? I took a screenshot. But it's also easy to figure out because you can unplug the toolhead board, and when the toolhead board is unplugged, you only have one. So that's not a big deal. Let's flash that. And now we should have two clippers. We have two clippers. Yep, and that's it. Technically, we should also have mainsail running already. No, it's not a port. I don't know which port it is. I guess 80 rocks. Yes, so technically we could start configuring stuff now. Just to confirm, like if you now go to printer config, there's nothing here yet, of course. But looking at devices, it should show us both the UUIDs, video, serial, nothing. But yeah, we have canvas. So that's all there. I wonder if that's now like, yeah, I mean, technically it's not that hard if you follow the guide. But yeah, I got up like at 5 a.m. this morning and it's like midnight now, so my brain's just like slowly going down. So I think for me that's like quite a good cutoff point. Streaming now for 6 hours, 5 hours, 15. But yeah, I think for today it's good. Because if you now start configuring, it will take like at least another 1.5, 2 hours until like the configuration is done. And then if we want to print something, we need to do some like initial, it's another 3 hours. So it will be definitely too late for me. But I mean, everything technically should be ready. Like all the electronics are there. So it's really just only the configuration. So unfortunately, no first print. I expected stuff to go a bit quicker, to be honest. But yeah, it is what it is. Then I need to check what my plans are for tomorrow. I'm not 100% sure yet. If I'm home tomorrow evening, then I think we can do like a Saturday special stream. Otherwise, I will just do it next week, Friday. But yeah, it's like pretty much like a printer now. Like, I mean, it is. That's the wrong button. It's complete. Like, it has all the things we need. It's really only software that's missing now. And the wiring looks super clean, so I'm very happy with that. The only thing I forgot is like we have to still this like little loop of cable here. I want to pull it down a bit. But yeah, besides that, it looks good. I'm building a 250mm one, and I think I'm going to have to mount my DIN rails horizontally, as the power supply doesn't clear the stepper motor. Yeah, the DIN rail orientation is different for the 250 and the 300. I don't recall details, but there was like something pointed out in the manual that the DIN rail orientation is different depending on the build size. So pay attention to that. Mine are in parallel with the extrusions here, so mine are going this way. And I think yours will be like this. Well, yeah, let's use that as a cutoff point. Thanks everyone for tuning in. Sorry for disappointing on the first print. But then we have something to look forward to next time. Enjoy your weekend and see you next time. Bye.